All right, so today we're going to do touchscreen interfacing, which we'll start with the basics as to host ports, what a host port is, how you want to structure your host ports, how you want to communicate with the system, and then I'll get to a basic example using our text interface as to these are the types of commands and these are what the most important commands that you're going to be using. And then we're going to finish off with, I'm going to use Wonderware InTouch to create a touchscreen using our PLC interface, which is kind of their extensions rather than using text is going to be using numbers. So I'll start out first with the basics. So I'm going to go bring up my little document here. So first of all, on our website is our host interface specification. So this is going to be the overall reference for your programmers. So it has the basics. There's two. You can control the intercom system through. Most cases, it's going to be Ethernet, so TCP/IP. But we also have a serial port available if you want to control through a serial port. Not many people do nowadays. Ethernet is, doesn't require any equipment. You've got Ethernet on all your devices. So most cases, you're going to be using some kind of Ethernet communications. We have two basic Ethernet communications. One is with text, so simply text over a serial port or text over an Ethernet socket. And it's just you send the intercom system text to make connections or send a command. An intercom system will send you a text response or a text message when, for example, an intercom call request is pressed. You'll see a ICRQ, intercom call request message. It'll tell you the master number that the call is coming into. It'll tell you the station number that's calling in. So it's a command followed by 1 to 4 arguments, and depending upon the command. The PLC interface is, so the intercom system can simulate a PLC, so it can look like a PLC on your system. So anything that on your system that can control a PLC can control the intercom system. It's just another PLC on the network.
I can put it on the computer.
Oh, there you go.
And so in that way, we basically take the text commands that you would send. For example, if you wanted to make a call connection, we have a intercom call command, ICAL. You give it a master number to connect from, you give it a station number to connect to, and it will do the connection. So that's, we can have a maximum of, just with the commands we have a maximum of 4 additional arguments other than command. In this case, it's command, a master number, an intercom number. But it could handle, there could be, other commands can have require more parameters. So with that in mind, it could be a command with up to 4 parameters. What we do is on our PLC type systems, we take the text equivalent. So you have a command and then 4 additional arguments. Well, we have a sequence of 5 sequential registers in our PLC. So those would be the command registers that you would send commands to. So you would send the command in the first register, the first argument in the second register, the second argument in the third register, etc. So instead of sending a text string, you fill out 5 register blocks, which does the same thing. It's the same format as a command and then the argument. So you have an intercom call command, which is a command 7. The second register would have your master number that you're making a connection from. The third register would be the master you're making a connection to. So the PLC interface is basically just a block of registers that will do various things. So I'm going to go over that in that section, but for the most part, it's going to mirror the text interface. It's going to be a command with arguments. our PLC interface is going to be only through Ethernet, so we don't have a serial equivalent to that. We can emulate two different PLC types. So we can emulate a MicroComm Modbus PLC using Modbus TCP, or we can emulate an Omron PLC using the Omron FINS protocol. So as long as your HMI software, your touchscreen software, your PLCs, if you're using a PLC to communicate to us, then you're treating the intercom system as another PLC. So as long as your PLCs can communicate with Modbus or with Omron FINS, you should be able to control our system from your control software, building control software, etc.
So you're saying that the PLC is basically I lost my thought. What is a type of PLC?
What is a type like the? Do you need to know what a PLC is, or
not really?
So the PLCs are basically just small computers that control your doors and whatnot. So they're basically a computer, but they're designed to control things. So they have lots of input output. So there's the intercom system, your locks and your door control systems will be controlled by ultimately a PLC. It's going to control all your solenoids and monitor your door lock switches and door position switches, and it's going to
record. A little computer.
It's just it's a little computer, exactly. So for industrial control, there's a few different main manufacturers of those programmable logic controllers. So it's a little computer that has basically it controls your solenoids, it reads your door switches, it does all of, may read some temperature, might have some temperature sensors, and all of that. It'll store that, and it can do things internally, or in many modern facilities, you have your server or your workstation PCs on your desk will read and write to that programmable logic controller or PLC to tell it to open a door or call up an intercom or something like that.
Right. When the button is pressed, I want you to turn the camera, call this desk, and do these different things in order these different commands.
Right. So some of that might be done by the control computer, your actual PC computer, but a lot of the PC computer doesn't have any control of your solenoids for your door control. So that's where it goes to the PLC. The PLC is going to handle the door control. So depending upon how the intercom system can be controlled either from your workstations. So your workstation can send a command to the intercom system directly, or your workstation might send a control to your PLC, just like it controls the doors. And then the PLC will send the intercom system a command. So from the point of view of the Harding system, it doesn't really matter. We're receiving commands from some other system, whether it's a PC computer or whether it's a programmable logic controller or PLC.
Okay. Thank you.
So whatever is controlling the intercom system can either send commands over text, or it can send commands to what it thinks is another programmable logic controller or PLC on the network. So we can be set up to do either way. The communication between systems we call a host port. So that's just the connection between the workstation PC or the programmable logic controller to the intercom system to do the control and for the intercom system to report status back. So we call that a host port. All right, so that's the host port. So I don't have a slide to illustrate this, but when we went over the DXL system yesterday, and I'll bring it up here. Now, what we have yesterday, it was a small system that had one DCC on it. So I created a host port. So that's the communication, the connection between the control system and the intercom system. And when I set up this host port, so you set up the connection as to which DCC it's going to be communicating with. So this will be which serial port it's going to be using if you're having a serial interface, or it's going to be which IP address you're going to send commands to. So that's going to be the DCC. So the host port is on a specific DCC. So you're going to send commands to that particular DCC's IP address. In the protocol, you specify whether you're going to use text strings, or they're going to simulate a programmable logic controller or PLC. Now you notice this is all grayed out because we've uploaded this configuration to the system yesterday. So the configuration is locked. I can't do anything with it. I can't unlock it. I can't edit it. So everything is grayed out, meaning you can't edit it. So I'm just going to go and save it as, just so it's a little bit more readable for you. So you're not seeing gray text on there. When you're using Ethernet, you're going to have so it shows you the IP address. This is not changeable. It's the IP address of the DCC, of this main exchange DCC. It shows you a port number, so you can, whenever you do an Ethernet connection to something, it has a port number. So some standardized protocols, if you use a web browser, you're using port number 80. So when you set up a host port, you're going to set up a exchange, which defines the IP address, and then you define the port number, which you're going to communicate with. So it's kind of up to you. You can specify things. There's some standardized port numbers, particularly for PLC interfaces. If you're using Modbus, the default port number is going to be 502. If you're using Omron, the default is going to be a port number 9600. But that can change, and if you have more than one host port on the same machine, you actually do have to have different port numbers for each host port. But I'll get into that shortly. So you define the port number and the exchange. Under the protocol, you specify whether it's a text messages or text strings, or whether you're simulating a PLC. So if you simulate a PLC, this gives me a warning I have to change the port number. So you can simulate either a MicroComm PLC or an Omron PLC, or there's a slight modification of a Modbus or Simplicity server software, which is Modbus packets with some additional information on it. So basically, you have a Modbus TCP or Omron, which is a FINS protocol, FINS. I go back to the text string here.
Hey, Darren, can I ask a few questions here?
Sure can.
Okay, so in the formatting that you're talking about, Omron FINS or Modbus or Simplicity, do you have any kind of information on what the variance is from those protocols to just regular TCP IP, or to Allen Bradley, or to Emerson? You know, how hard is it to integrate this system with like a Rockwell PLC or an GE Emerson PLC? Can you kind of dive in on that a little bit?
So Allen Bradley, their protocol, we wanted to do their native protocol, but it was the restrictions on the licensing restrictions for that were very onerous. So the Allen Bradley native protocol is something that we don't support at this time. Now, almost all these PLCs, they have some sort of way to communicate to other PLCs. So most of them will have some sort of option to either communicate, well, many of them will have an option to communicate with Modbus TCP. So it's not just MicroComm PLCs that communicate with Modbus. So Modbus might not be native to things like Allen Bradley, but it's something that you can do. You can get a driver for, you can get an I/O card for. I honestly am not familiar with Emerson, so I couldn't give you anything
so
on that.
in using an HMI like Factory Talk, what I need to be able to do is I need to be able to make the PLC communicate with the exchange, but I also need Factory Talk to update and to give us information off the exchange also. So I think Rockwell has drivers that I can use to communicate through Omron fins. But you're saying that pretty much the whole communication back and forth between the exchange and the PLC, I'm essentially just going to be limited to Modbus TCP.
Well, we have a fins option. So if you have an option to do fins, you can talk to the intercom system through fins.
But not well, so I can do that with the HMI part, but not with the PLC.
If the PLC can communicate to another PLC over fins, then the intercom system just another PLC on your network.
Okay.
You do natively fins, and then we're just another fins PLC on your network that you talk fins to fins.
Okay. Thank you.
So we have the two options. You can communicate to the intercom system with Modbus, or you can communicate with fins. And some people they put a Ethernet, they put a text Ethernet card in their system and they communicate with text. So it's up to you, but most cases you'll have some option to natively or at least do a protocol conversion to Modbus or fins, which is probably free. There's no additional card required, depending upon the system. I know Allen Bradley, they do have to have an additional card in, or at least customers that inform me on that. So anyway, so we have the options as you can communicate text, or as emulate an Omron fins PLC, or emulate a MicroComm PLC. And then you use whatever driver you have in your HMI to communicate Modbus. You use your Modbus driver, treat the intercom system like a Modbus PLC on your network. So I'll go into this Masters tab. So this is where your programmers and how you design your network or design your communication, you have a choice over here. So a host port is a communication path from your control system, whether it's a computer or whether it's a PLC, to the intercom system. If you want, you can have one control path to the system. So a common example would be you have a server. So all of your PC systems communicate to a server on your system. And if you want the server to communicate, to be the only one that communicate with the intercom system, you would create one host port. That's the communication path between the server and the intercom system. And in that case, so no matter which workstation is making a call to its local master station, all the commands will flow through that one server, to the intercom system. So that would be one host port. So one host port will control all the masters on the system. And actually, before I even get to that, I'll go into how our system does control. So I have on this screen right now the masters tab on the host port. So a master station is something like touchscreen master module, or an IMS. IMS master here, or an IMS 641, or it could even be a telephone. So each master has its own independent connection through to the system, because we don't have any banks of relays, any master anywheres can talk to any station anywheres. All you need to know is the master number that you're connecting from and the intercom station number that you're connecting to. You don't need to know about how to connect it up, which switch banks to turn on, which disable any master amplifier so you can forward it to central control. You just tell it where the master is, where the station is. It will do the connection, whatever connection is necessary to get that master to connect to that station. As such, you do not, if you're talking from a central control master to a unit station, you don't need to do anything with the unit master. The unit master is its own separate thing. So all you need to do is you tell the intercom system, I want to connect the central control master to the unit station. That's all you need to do. You don't need to do anything else. So as such, anything you do on a central master, you send to the central master. You don't send it, you don't need to send commands to anything else. You don't need to send commands to the unit to talk to the station and then send a command to the central to listen to the unit. You just send a command to central. To the master that you are controlling, you send a command to that master. You don't need to do anything else. So as such, in how our system works, is a master station in the host port section. So you assign which, well, you can go look at it from a master station. A master station can only receive commands from one place. It's going to be its control system. So you can't have multiple computers, multiple workstations sending commands to the same master. You can only have one. The master will accept commands from only one place, one host port. So there's no need for central control to send a command to the unit master because you don't need to switch anything on the unit master. Central control will send a command to central control master. So as such, a master can be controlled by only one host. If you try to click a second box to make it assign it to another host, it will move it to that one. It'll remove it from the first one, put it on the second one. So it can only be controlled from one place.
Darren, quick question on that.
Okay.
Pretty sure I know the answer, but you guys don't have any sort of failover for that, right? If that exchange happens to go down and you've got masters communicating to that exchange, there's no way for that master to connect to anywhere after that. Is that correct? Correct.
But in general, that's where I'm coming to the point how you distribute the host port. So if you distribute them such that the host port is controlled by, like a master on an exchange is controlled by a host port on that exchange, then that becomes that doesn't become the big part of the problem. If the exchange is down, you can't talk to the exchange. So whether or not so you can't talk to the master, you can't talk to the exchange, you can't do anything. So that doesn't bring anything further down. That will come to my point on that coming up right away here. Is so a master can be controlled by one and only one host port, but a host port can control multiple masters if you want. So you can have a connection in the case of the server. So if I've got a system that has multiple DCCs and I have one host port on one of the DCCs. Now you could have a central server talk to the one DCC to send commands for all masters everywhere in that system. So masters on that DCC, masters not on that DCC. So that's the simplest mechanism. But as you mentioned, that's not the most robust mechanisms, because if that one DCC loses network or goes down, you can't control any masters on the system because all the masters go through that one host port on that one DCC. So it's simple. There's only one connection, but it does mean there's a failure problem. There's a problem that if that one fails, then you can't communicate to other masters, even if those other masters are on exchanges that are working. So that's the simplest, is all the masters controlled by one host port on one system, one DCC. The other extreme end of the range is that you might have a host port for each master. So if I have 4 masters on my DCC here, I would create 4 host ports on that DCC. You'll have to have different port numbers. So if I'm using a text host port, it'd be like maybe 10,000, port 10,000 is number 1, 10,001 is number 2, 10,002 is number 3, etc. So you have a separate host port per master. So this might be commonly used when you have the workstations directly controlling the intercom system without having to go through a server, without having to go through a PLC. So that's the other extreme of things. You have one master per host port, or one host port per master. So you can do that, and that one works as a perfectly valid solution. Every master, assuming that you put the host port on the DCC that the master is on. So if the host port is on the DCC with the master, then if a DCC goes down, then only the masters that are on that DCC are unavailable. And then, so that one's a perfectly logical, perfectly reasonable. If you want to do it that way, you can do it that way. A happy medium that a lot of customers use is to create one host port per DCC, and then all the masters on that DCC will use that one host port. So you have one connection per DCC. If I have 4 masters on my DCC here, then I would have one host port, but all 4 masters on that DCC will go through that host port. So that one is probably the most common, maybe 60%, with probably the other 40% of users using the one host port per master. So it's up to you for doing that. Both will give you the same amount of system robustness, but it's kind of up to you. A server approach, everything going through a server or everything going through a PLC, and then that going to the intercom system makes more sense for a host port per exchange. If you're directly controlling from a workstation, then a host port per master works, but host port per exchange will work too. You can have multiple computers connecting through the same host port if you wanted to. So that's still an option. So it's up to you as to how you want to split the system up with the host ports. My recommendation is probably just start simple, one host port per exchange, all the masters on that exchange report to that host port. So as such, that's what this configuration screen you see in front of you is for. So on my host port, on my one DCC that I have, you can go in here and you can assign, okay, which master stations are being controlled by this host port. If you select a master station here, if it's assigned to another host port at the moment, it will move it to this one. So a master can be controlled by only one host port. So in this case, I'm controlling master control, touchscreen control, the unit master, and that optional 4th master I'm putting in. These are all going to be controlled by my touchscreen, my host interface. You can look at it from the other way. As I mentioned, there's multiple ways to look through our configuration. So we're looking at the host port, looking at which masters you can control. You can go into the masters and see which host port controls them. So changing this setting on either side. Control, there we go. So changing on either side, if I assign this host port controls all my masters, if I go to my masters, it'll show the host port that controls it, or you can change the host port that controls it.
What tab did you click to get to that?
This is the control tab of the masters.
Okay.
And you probably don't necessarily need to go through this way. You going through the host to see all the masters, but you can go either way, looking to make changes or to look at the settings. Just like when we were looking at permissions for masters that can call a master, so you can either go to the master that's making the call and see which masters it's allowed to call, or you can go to the master that the destination. You can see which masters are allowed to call it, and the same thing for the host ports. So under the host ports, you assign which masters that this host port can control. Like I said, a master can be controlled by one and only one place. All right, as such, so lots the control aspects of things. Now, the text, I'm going to start with the text interface. So a host port is basically a place to a communication path for you to send commands to control the intercom system and to receive responses or receive updates from the intercom system. So, for example, a command would be a command to connect a master station to an intercom station. Command can be disconnect the master station. A response could be the command that the connection was established. A response can be intercom number 101 call button was pressed and reports to master 1. So those are the kinds of commands and kinds of responses that you would typically have on our system. We have a lot of commands, and this document, the host interface specifications on our website in the training section, goes over a lot of the commands. There's a big summary of commands up in the front. So every command is a 4-letter acronym. For example, an intercom call is ICAL. Makes a connection from a master station to an intercom station. When intercom station presses this button, you'll see a response that says intercom call request, ICRQ. So you can look further in the document and explains what all those are, what the parameters for these are. So for example, if I look at the intercom call, or I could just use that table in the front. It's a clickable link. Intercom call. Or it was a clickable link at one time. Maybe it isn't time. Oh, this is a. Okay, it's not clickable anymore. It used to be. There we go. So intercom call. So that's the 4-letter text command. And if you're using a PLC logic, the numeric equivalent is command 7. And you give it the parameters. You go intercom call, and then the master number, and then the station number that you're going to call up to. And it gives you an example. I call 10, 11:30. Calls from master 10 to station 11:30. So I'm going to show you some examples here on our live system. So I'm going to use a text terminal program. I can never remember which one I have on here. Putty, that's what I have. P-U-T-T-Y. So if I look in, I configured my host port on port 10,000. That's under the connection status. I did, but we messed around. Okay, don't make any changes to it. I'm going to exit this. So if I look at the loaded configuration, that's with the lock symbol on it. Go to my host ports. It's a Ethernet text on 10.0.1.96 port 10,000. So I'm going to go to my terminal program and I'm going to set the communication parameters N0196 port number 10,000. It's going to be straight text. I make some changes afterwards, but I'm going to go ahead. Save that. And so I'm going to do a couple other parameters because it's so we use Unix style line feeds, carriage returns. We're going to have a carriage return at the end. And a line feed. So I'm going to go and set the terminal settings. I'm going to set echo on. I think that's all I need to do. And I'm going to connect to the system. And make this text bigger than what can. Okay. So when I first connected to it, you'll see the intercom system sent a response as active. So you have reached a hardening system, and you have reached a DCC with a host port that is in control. So that just knows that, yeah, you connected to the right place. In the case of this also makes this compatible with our DXI system, which you had the ability to, we had redundant computers, so you had redundant connections, so you can connect to both of the computers, and the active computer will send you the ACTV message saying that this is the active computer. In the case of the DXL system, we have no redundant controls, so you're always going to reach the active one. Now, you'll see that at periodic intervals, you see this no-op message coming in. And was mentioned yesterday is, can I determine if the DXL system is healthy? On a text interface, this is the way to determine that you've got a working, or you've got a connection on and working or healthy system. As the intercom system is programmed, part of the control in this settings here under monitor, there is a checkbox that says monitor connection for faults and a timeout. So what it does is that every 10 seconds it will send a message that says no op, indicating that the intercom system is still working. We're still working. It's still working. So that's what all these no ops are. So when I do a slight change in the configuration, I'm going to turn that off because it makes it a little more difficult for you to see things as we go through. But that's what those no-op messages are. So just a simply system, the message saying system is still communication, system is still working. So if I was to do a simple communication, simple control. So I have an intercom, and I'm going to press my call button on the intercom. You will see these ICRQ messages come in. So my circulation intercoms are set up so that they control central control master, which consists of masters 1, 2, and 4. So that group consists of masters 1, 2, and 4. So when I press the call in button, and since masters 1, 2, and 4 are all controlled from the same host interface, I see a call request going to master 1 from station 401, call request going to master 2 from station 401, and call request going to master 4 from station 401. So your control system logic would see those messages, and it would put, it would do the appropriate things to indicate that that station is calling into each of those control workstations. So if I wanted to make a connection to that intercom, then I can use the intercom call command. ICAL master station. So I sent the command intercom call. It established the connection to the intercom station. You heard the beep. You heard the beep. Part of that is now that you've answered the call, the call has been acknowledged. You no longer need to show it on the incoming screens because you're already connected to it. So the first thing it does when you establish the call is it sends a cancel message that says you can cancel that call in from master 1. You can cancel the call in from master 2. You can cancel the call in from master 4. ICAN. So it'll cancel the call in. And as I mentioned previously, if you got a master group, if you answer it from any one of them, it will cancel it off of all the other ones. So that's what it did here is I answered it from number 1. It canceled it on 1, 2, and 4. Then it gave me a response. It says it was done. So it successfully completed the command that I sent. It successfully connected. Successfully did the command intercom call 1 to 401. So this indicates that it successfully made a connection from master 1 to station 401. So I can send the command to end the connection, and there's a number of different commands to do that. So you can send an intercom call from that master to station 0. That disconnects it. You can send a command intercom, or you can send a command end call ENDC and then the master number will end whatever that master is connected to, or you can send a command IEND intercom end and then the master number and the station number. So I'm going to go and use the end call function ENDC1. So I'm going to end whatever master 1 is connected to, and it successfully ended the call. It gave me a message that says done. End call 1. So I successfully completed disconnecting that call, whatever was on master 1. So that's the basics of the text interface. Now I'm going to show you some more commands with that, but what I'm going to do first is I'm going to first of all change the settings. So first of all, I show you here that when a command was successfully completed, it gives you a done response. So done and then the command. So before I do anything further, I'm going to show you, you don't normally need that. So, but I'm going to show you what, if you wanted to use it, why that option is there. So I have a master station. Right over here. And so I can place a call in. You'll see it show up on the master station display. I have an intercom call in from 401. You'll see that the touchscreen interface, the host interface, received that call request, including master 1 we're at. But I don't have to answer it from the touchscreen. This master has an answer button on it, so if I press the answer button on it, I can establish the call to it without sending a command. But the intercom system will keep you updated that this master is connected by itself by sending you the intercom call command. So it says that the intercom system connected master 1 to station 401. And likewise, if I end it from the master station, it will send you a response saying that it ended that call. So it sent a response, intercom end, so it ended the call between master 1 and station 401. So the intercom system will send you updates even if you didn't ask for a command. If the operator called an intercom, so I can, for example, I can go and press the call and then the station, and then I could select an intercom station on the screen. And hit accept. So the master station can place a call by itself. And if it does so, then you will see a response that says intercom call 101. We'll end that again. But if you send a command to do it, and that's where that no-op broke it up. The command I sent was intercom call 101. The intercom system successfully responded to the request by the touchscreen, so it sent a done iCall 101. So if the intercom system by itself made the connection, you'll see intercom call 101, and if it was a response to something that you sent, you'll see a done iCall 101. So if you wanted to, you could differentiate something user initiated versus something touchscreen initiated. But that means your programmers have to go, now they have to look for that intercom call in two places. One by looking for the intercom call just by itself, and another one with a done with that in front. You don't normally need to differentiate that. So the intercom system has an option to turn that off. So everything that you send, whether it's initiated by the intercom system or a response to something you did, will look the same. So it will show up as intercom call 101, whether you sent the command or whether the master did it by itself. So that's the next setting I'm going to change. So it makes things easier for your programmers. They don't have to write their code to handle both cases where there's a done in front or there's not a done in front. And I'm going to turn off this no-op messages so I don't doesn't get interrupted. You'll notice that there you see this date message in there, so that the system can you can update the intercom date and time, or the intercom system will update you with the date and time. This is the so it's a periodic interval that will send that out, and you can set the date and time, or you can use an NTP server. So I'm going to close this. I'm going to go and go in my changed configuration. So I just saved it as I didn't make any changes so far. So what I'm going to do is I'm going to change a couple of things. So under the messages, you see this response messages section. It says respond to all host commands. So the way it is right now, the default when you create a new host port, it's going to send a done if you as a response to a command that you sent, and no done if the system does it by itself. If you check mark this second box, that basically says don't send done. So send everything without a done. So whether it's initiated by the intercom system or initiated by a host command, the response you see will be the same. This top checkbox means send everything with done. Unchecking this means you don't get a response at all. So if you send a command, you won't get a response back that it was successful. So this one is what I recommend. Respond to all host commands. You get a response whenever you send a command, and that the response takes out the done in front. This other checkbox below here is another way of so when the intercom system sends you a for example, call request, it will send you an intercom call request command, ICRQ, master number, station number. It only sends it once. When the master gets a new call in, your host gets a new call. It gets queued up on the master station queue. The intercom system will send you a host command that says intercom call request. I'll just go and I'll illustrate that when we do the change. So it will only send that once. So you want to make sure that your processing code has no bugs in it and there's no way for it to miss a message or to be too busy or to skip something. So if it missed the call request and the intercom system sent a call request message out and you didn't act on it, now the intercom system knows that there's that call request button is pressed, it's in the queue. Someone presses the button again, it will not resend that intercom call request because it's already in the system. So that may mean if your system can't, for some reason, didn't process a message, then the intercom system thinks it's calling in, your system doesn't think it's calling in, and the intercom system will not retransmit that because it's already in the system. This acknowledgement, if you're using a text interface, this acknowledgement is a way for, if there is some circumstances that you can't work out in your software that you can't, for whatever reason you miss something once in a while. That's what this is for, is the acknowledgement is if the intercom system sends you a call request message, it's going to wait until you send an ACKD, and then the message. And then it knows you received it, you processed it, and it will send you the next one. Otherwise, it will give you a timeout. It will resend the message and say, you missed this one. So this is a way for a text message to have a response. So whenever the intercom system sends a message out, your system needs to send a response back saying, yep, I got it. Give me the next one. You don't need this very often. So this is there as kind of an emergency measure or as an extra check if you want. But you don't normally need to use this. All right, that being said, so I'm turning off the done response with this, and I'm going into the monitor section. And this section here is where the no-op messages are sent. So if I uncheck this, it's going to no longer send the no-op messages. And this timeout is how often it sends those messages. On the messages tab, I'll just kind of describe what you're seeing on the left-hand side. So this left-hand side, you can use both as a reference for the different commands. So this tells you the commands and the command number. So if I want to know what ICAL is, I can go scroll down. ICAL is command number 7. But it also, again, it's not really recommended, but so it shows you a checkbox. So you can disable a command so that it won't act on the command and it won't send that command out. So now what we recommend is, so the intercom system will send you a text string with any updates. And you're probably only looking for a few things. You're looking for a call request. You're looking for a cancel call request. You're looking for a call request. You're looking for a cancel call request. You're looking for an intercom call, successful connection. You're looking for an intercom end, successful disconnection. So you're not really, you probably don't care that if you have the system can report a hardware fault, so it can report a station faulted. It can report a music has been changed. So it could have a whole bunch of different messages that you're not really necessarily, you don't have a place to show them on your screen, or you don't really need to know about that. But the intercom system will send you those messages. If your logic takes the message and acts on it, but it doesn't have a fall-through case that to handle anything that it doesn't know about, then you can cause your logic to do something bad. So it might hang up waiting for a valid response. So ultimately, you should ignore, if it's a message that you don't understand, you should just ignore it and go to the next one. And then you don't need this. But if you have an older, say for example, you're upgrading a DXI system to a DXL system, and you want to use the exact same control system, and for whatever reason that control system didn't ignore messages it didn't understand. Well, there are some messages that are sent by the DXI system that aren't sent by the DXL system, so or that are or vice versa. So you can go into this and you can uncheck the messages that you don't want the intercom system to send. And then it won't send them, it won't act on them. So it can make it compatible with an older driver that you've written that doesn't understand that command and would cause problems if you do that command. So you can disable sending and receiving certain commands. But in general, it's not, you don't need to do that. It's really only if you got a a really old driver that was written by maybe another integrator. You can't change the driver, but for whatever reason it goes bad whenever when these new commands are sent. So you can disable any commands that you don't want it to send, don't want it to act on. So turn the monitoring off. These are still going to have the same master. So now I'm going to go and you make any changes, you have to make a change the number. So I've already, oops, I don't need to save that. I need to save. You make any changes, you have to reload it on the system and reactivate it. So I'm going to go into File, File Manager. I've got a new configuration with my host settings changed. I'm going to connect to the system. I'm going to select it and copy it. I'm going to select it and activate it, which will cause a restart. I'll wait for it to start up. All right, so it should be started up by now. I'll close out of this. I'll go and start up my PUTTY terminal program. Load the last settings. All right, so now I'm connected. It says that I'm on the active system. It's no longer going to send the no-watt messages because of my settings. Now you're going to see a bunch of messages. So if you look at my master screen, so I've set my master to, if there's any intercom faults, it's going to report on the master. So I have F and then 102, so I don't have intercom station 102 connected, so it's telling me 102 has a wiring fault, which is good. That's what it is. 103 isn't connected, so I'm hitting the next answer next button to clear that off, just like hitting acknowledge on the front panel of the DCC. So I have all these intercoms that are not connected. Now what you'll see on my host port, you see a HAC. So that's the message says hardware acknowledgement. So it's acknowledged that master 1 cleared the hardware, acknowledged the hardware fault for station 102. They acknowledged the hardware faults for station 103. So again, this might be one message that you don't care about, but the intercom system will normally send to you. All right, so my screen is now clear. I can go and do another example call. I'll press the call in button. I've got it. The call-in shows on the master station. It shows on my touchscreen intercom call request on going to master 1 from station 101, going to master 2 from station 101, going to master 4 from station 101. So I can answer the call from the master station or from the host port intercom call. Oops. 101. The case does not matter. So we don't, whether you type it all caps or all lowercase or the way that we send it. So we will always send it the same. We'll send it the way that that's in the documentation, but we'll accept uppercase, lowercase, doesn't matter. So hitting, sending the intercom call command, it establishes the, well, first thing it does is it clears it off of the queue list. So it sends a cancel command to master, from master 1, to master 1, to master 2, to master 4. It then acknowledges that the command that the station is successfully connected. The master 1 is successfully connected to station 101. Before we made that setting change, it sent a done iCall 111 saying the master station, the host initiated this. This is a response to the host. I've turned that off, so now whether the master initiates the call or you initiate the call, you only need to look for one action. You only need to look for the iCall. So this makes your programmers happier. It's easier to program this when you only need to look for it in one place. So intercom number 1 was successful, or master 1 was successfully connected to intercom 101. Now you want to do things like you want to use the intercom system's responses for call requests and for call request cancels. And the reason for that is, say for example, I press my other. So you want to use the intercom cancel rather than, well, if I make a call, well, yeah, I'm canceling it. So you internally cancel it on that. There's a reason that you want to use all of our response messages. And I'm going to show you the reasoning. So I'm currently connected to intercom 101. Say for example, I'm going to go and have a call request from 401. All right, so now I have an intercom call request from 401 going to master 1, 2, and 4. So I can go and I don't need to end the call on the, so currently I am currently connected on master 1 to intercom 101. But I can make a call, intercom call from master, whoops. And I just hit some, just hit enter and it said a syntax. So it can give you a response that says syntax. Whatever you typed in was invalid. Whatever you sent was invalid. Intercom call 1401. And what we'll do is, because the intercom system, you can't, it's not like a relay-based system where you can't connect, you can't push multiple stations and connect to multiple stations because of our digital switch, one input to one or one or more outputs, but not multiple inputs to one output. So when I connect to another intercom from this master station, it's going to disconnect from the first one, and then it's going to connect to the second one. So you can see a command that you didn't explicitly specify. You can send a command that says it disconnected from the first station, and then it connected to the second station. So you're going to see it sent the command IN. So it told you it disconnected master 1 from station 101. You didn't send that command, but it's a response. It had to disconnect it in order to connect to your new one. It then canceled the call in that was coming from 401 off of these 3 masters, and then it successfully connected master 1 to 401. So this string basically says it had to end the call on 101, so that you can use that to set your icon on the screen, so that's no longer active. And then the cancels will cancel the call request actions on your screen. Usually it's a flashing icon. And then you have the successful connection between master 1 and 401. So that will now flag the icon for 401 being in a call connection. So the intercom system can send you updates that you didn't ask for just because it had to disconnect that, so it sent you a message that says it disconnected that. So always on a DXL system, it will tell you which station it's disconnecting from. Question: are any of you maintaining an existing DXI system or doing an upgrade from a DXI system? Okay, I don't get a response, but I'll just give you a gotcha on that. So the DXI system and the DXL system they use the same command set. So for the most part, anything a DXI does, a DXL can do. Or if you have a DXI driver and you're upgrading your system to DXL, you just put it in. The DXL will understand the same commands. There's one exception, or one thing the DXL does better than the DXI is, you see when I disconnected that intercom, it told me not only that it disconnected master 1, but it told me the station number that was connected to. So you can unset that icon. The DXI system didn't do that. The DXI system will only send you a command that says end call ENDC, and it gave you the master number, but it didn't tell you the station that was disconnected. So the DXI system, because we didn't have that, any programmers using a text interface or this interface on a DXI, or using a DXI system in general, when you make a call connection, you have to keep track of which station that you last connected to, so that when you see the end call coming back from the intercom system, you know which icon to turn off. So it will only have sent the intercom, it would only have sent the end call rather than the IN. So it would send end call 1 rather than the IN 101. So that's the difference between DXI and DXL. That's another application for the host port settings here. I'm going to go save it as a third name. So if you have a DXI system that you are upgrading to a DXL, now part of the host interface specifications tells you exactly what I'm going to show you, but it basically tells you if you want to ensure you have DXI compatibility, so that if you're changing from a DXI system to a DXL system and you're not changing your control system, you can disable the new DXL commands and it will revert to the old DXI commands. So if I go into the messages and if I turn off the IND command, now whenever a call is ended, it will use the DXI compatible end call command instead. So this is another application for these disabling messages. So you can disable the messages that DXI doesn't send, so the DXL will operate the same way the DXI did. So it'll be IND, BEND, MEND. So any of the end commands are something that the DXI did not send. MEND, BEND. Really, the only thing anyone's going to be using is probably IND. So, and then PEND, page end. Master call, end of a master call, end of a intercom call, end of a page call. So you can disable those, and then it will act like it's a DXI system, and you can use your existing DXI system driver with a new DXL head end, and not have to change your driver to work on those. All right, so the intercom system, if you connect from one station to another station, it will automatically disconnect from the first station and then connect to the second station. All right, so I have my, I'm currently connected to station 401. I'm gonna go and press 101 again. So I got a call in at 101. So the intercom system can operate independently of your control system. So what if I reestablished my connection? So now I've disconnected and I'm reconnected. I'm going to okay, so I've reconnected and it just says active. But I actually have a call in progress right now, and I have a call in the call queue, but I don't see it here because that activity happened when the control system was disconnected, it was rebooted, or you disconnected it. So right now you don't see this active call, and you don't see that call request. So there is a command to resynchronize any activity on the system since you were down, so that you'll know about all current activity. And that command is, there are two commands. There's a command based on a single master called stat in the master. And there's a command for DXL only. There's a command for reporting all activity on this host. So I'll start with stat. So DXI has the stat, DXI does not have all stat. Stat 1. So it tells me all activity related to master 1. So it says, first of all, it sent a done stat 1 saying it accepted your command and it's processed your command. And it says enable, so I haven't mentioned this yet before, but enable is whether the master is manned or enabled. So this says master 1 is enabled. So it's active, it's not logged out. You have an intercom call request going to master 1 from station 101. You have all those acknowledgements, so those hardware acknowledgements were on the master, were acknowledged by the master. And last thing, it says intercom, master 1 is an intercom call to station 401. So you see those messages exactly as if that action happened right now. So you don't need to write anything special to see if the station is calling in or if a master is in a call. These will all get sent just the same way that if someone pressed the button right there. So you don't need any additional logic. You send the stat, and then it'll send all of the activity as if that activity happened right now. So that's a way to resynchronize. When you reconnect to the system, you send a stat command, and all stat is the same thing, but it sends it for all masters. So if I look at all stat, so it tells me master 1's enabled, all the acknowledgements on master 1, master 1's connected to 401, it says master 2 is enabled, master 3 is enabled, master 4 is enabled. So the stat and all stat will allow you to resynchronize when you reconnect to the system. Now I mentioned if sometimes your control system shouldn't ever have to, but sometimes there's either due to how, I don't know the conditions, it's up to the programmers, but sometimes I find that the intercom system will send, say for example, a call request message only once. So if I'm over here right now and I press that call button again, nothing happens. You're not getting any additional response because it's already in the system. So sometimes, for whatever reason, the programmers, something happens and they miss a message. And so sometimes I see a kludge where the programmer can't fix it. So what they will do is they will periodically send the stat message just in case they missed it. They'll pick it up again. So if I send stat 1 again, so in case they missed it, it comes back again at this stat. So that's something you can do. I don't recommend it. I recommend finding the problem and fixing it. But what this can do, if you do have to do this, don't do it often. Like, don't do it every 5 seconds because it's going to cause a lot of excess system load reporting this set of messages every 5 seconds. So do it at a long interval. But also, if you do that, just keep in mind that from the user standpoint, that those call-ins look like they happen right now. So if you have to do this kludge, keep in mind that if you do miss something, and if you say have a 5-minute interval, and you missed it the first time, it shows up 5 minutes later, the staff goes, there's nobody there. Why did this station call in? And it's because it probably called in 5 minutes earlier and it was missed. And now there's nobody at that door. When they look at the camera, there's nobody at the door. So just keep that in mind. If you do have to do this kludge, you may get reports like that. It's like, there's no call in here. So, so just keep in mind, so the stat is very, very useful for when you reconnect to a system. So when you first, you do whenever your control system starts up, makes a connection to the intercom system, you send a stat command or an all stat command to reestablish with whatever the intercom system activity has been up till now. Same thing if you see that you lose the connection to the system and you reconnect to it, first thing you should do is send a stat command or an all stat. All right, so I'm going to go and clear these off of the system, and I'll show you some other examples in the text interface. All right, so now the next thing I'm going to show you is some of the more advanced features. So you have the intercom call, which is the, let's go back into my little text thing here. So this one, yeah. So you have, so the intercom call request is the call request button being pressed by the at the station. To make a call, you use the intercom call command. It will send you a cancel. Then you can use the end call to end the call, or the call and then station and 0, or the end. So that's, and then you can do the same thing for if you're making a call to for a paging zone. Instead of ICAL, you'll use the page command. Page, the master, and then the page zone number. And then you can use the page end instead of the end. Or you can simply use the end call, which will end whatever is on that master. You could do a master to master call. So the M call, this master, and then the next master. Now, master to master calls are kind of special. Now, occasionally we get a request that, normally a master station calls an intercom, it calls a page zone. Well, you can call between control rooms with the master to master call, but the master is normally in control. The master makes the call to a station. The station doesn't automatically connect its audio up to the master. The master decides when they want to answer it, so that they may be in a private conversation with another officer, and they don't want someone presses a button and they'll immediately hear what the officer's saying. No, the officer wants to be in control and accept the call when, okay, here, hold on a moment, I'm going to talk to this guy. So usually it's the master, the control room, workstation, or whatever, the officer at the master station is in control of when he establishes the call. A master to master call, you have now 2 control room officers. A call between one officer and another officer. So normally with our system is if you establish a call between masters, so if it's a master with a telephone interface like that, you'll see just like an intercom, you'll see a master call request. You see an M in the front instead of an I in the front. So if I press a intercom, I'll show you that on the screen. So you see I, and then 101, and then the descriptive name. So if this was a master making a master to master call, so another IMS master dialed this master, you'll see an M, the master number, and the description of master name, and then they can go and select it and select answer next or answer. And so they have control of when they're answering the call. So the master making the call will get a ringing noise, just like you get on a telephone. So you get a ringing noise that's waiting for the guy on the other side to connect. You'll see it on the screen. You can hit the answer next button. So if I was to, I'll show you that example right now, is I will send a command to do a master call, master 2 to master 1. You might hear in the background that my master 2, my speaker is ringing. And if you look at the master display, I have a master calling from master 2, which is the touchscreen master. And it won't establish the call until the destination master wants to answer the call. So now I press the answer button. And now I'll see the confirmation that master 1 is now connected to master 2. Actually, I'll show you a little more detail here again. So we'll start this again. M call master 1. Master call. So that's master to master call. That's just kind of a note on master to master calls. So I'm now going to get into some more advanced options. Now I mentioned that the system has the ability for a secondary master, that if a master doesn't answer a call within a certain period of time, it will fail over and go to a secondary master. So that can be on a timeout basis, or that can be on, you can man or unman a master. So I'm going to demonstrate that right now. I have my unit intercoms are going to call into unit master number 3. So I will initiate a unit intercom call in right now. My unit master is also controlled by the same host port. So what you'll see is I have a intercom call request going to master 3 from intercom number 204. You'll hear my telephone ringing, indicating that master station has that call on its queue. If you don't answer that call, I'm just going to see how long we have to wait. What did I set the host port timeout for, or the master timeout? Under the secondary tab, it will be 1 minute, 60 seconds. So after 60 seconds, what you're going to see is the call request will also get sent to the secondary master. There we go, which is master 10, which is the central control group consisting of masters 1, 2, and 4. So after the 60-second timeout, you'll see I got the call in going to 1, 2, and 4 as well. Once it's forwarded, answering it from any of the masters. So if it's answered from the original master, it will disappear off of all 4 of them. If it's answered from central control, it will be cleared off all 4 of them. So any one of the new masters answering the call in will answer it and will clear it off. So I'm going to answer it from the original one, which is master number 3. You'll see that it cancels from 1, 2, 4, and 3, and then confirms that the call was connected from master 3 to station 204. I'll end the call. And I get the end response. So that's the timed forwarding. So it did after the timeout, it got to central control, but it took 60 seconds. If that unit is not staffed, there's no need to have that delay on there. So you can tell the unit that's unstaffed by disabling the master. So the command to do that is enbl enable, then the master number, and then 1 to re-enable it, or 0 to disable it. So if I go enable, master 3 is now disabled or unmanned. If I was to press that calling button now, I get an immediate response on my central control stations. So intercom 203 is calling in master 1, 2, and 4. So it doesn't have to have that timeout if you unman that master. Now, if this call came into central control, the enable and disable the system knows the intercom the master that it originally came into. So this was supposed to go to the unit master, but the unit master is unmanned. If central control hasn't answered it, and then the unit master comes back, and so now the shift comes back in, and they've re-enabled it. What will happen is the call-in will disappear off of, if it's less than a timeout, the call-in will disappear off of the central masters, and it reappears on the master came to. So that came up to this point. So it canceled it off of 1, 2, and 4, and then it put it back on the master 3 when I re-enabled it. Shortly afterwards, the 60-second timeout happened, and it went back to 1, 2, and 3, or 1, 2, and 4. But if you re-enable things, it will go back to where it originally came from. And if it didn't have a timeout, then it wouldn't come back to this one. So if it originally went to a master station and it was forwarded because it was unstaffed, when you re-enable it, it goes back on that one. It goes back off the old ones. And the same thing is if I'll go and answer that first. And the same thing happens if a master is enabled. So if it's on a call request is on my unit master and I disable it right now, then it will immediately forward it to the secondary. So it knows if you enable or disable a master, any calls that would have gone to that master will automatically get re-forwarded. And when you enable it again, any calls that were originally going to that master will come back to it. And you'll see it by canceling it off of the forwarded masters and going back and being call request back on the original master. So that's one way of forwarding is you can basically, if you have a fixed scheme, so unit calls come into the living unit calls come into the living unit master. If the living unit master is unstaffed, it goes to a secondary, so maybe a floor control master or maybe a central control. So you enable the master, so when unit master is unstaffed, disable the unit master, it goes to where it's forwarded to. If the floor master is unstaffed, disable the floor master, and it goes to central control. So that's one way of doing things is you have the fixed secondaries and you just use enable, disable to automatically forward through to its local control. So this enable, disable can be not only just unmanning, but if you got like a riot or a takeover condition, you can use the central control can send a message to disable that master. So that all calls will go to central control, so they can't do anything with it. So that's one way of forwarding is it use the enable and disable to set to unman a particular master. So I'm gonna go and just clear this again here. So you can do things even fancier than that. So an example I gave earlier is you might have two adjacent living units that so during a busy part of the day, every living unit, the living unit master handles its own living unit intercoms. During a slightly quieter periods of time, you might have living unit A forward calls to living unit B master when it's unstaffed. So you have someone in B when A is unstaffed. So you might want to change things. So instead of going into central control when living unit A is unstaffed, at least temporarily you want it to go to living unit B when the unit A is unstaffed. So there's no conditionals in the configuration. The configuration only has, if this master is on this master is secondary, this only has one secondary. So in the configuration, it can only go to one place. So it only go to, say, a floor master or a central master. But if you want to do something like this, and you have the ability to send the commands to that, what you can do is you can change on the fly, or at least temporarily, the secondary master for a master. So if I want to have master 3, which is my living unit master, if I want to have it temporarily forward only to master 4 when this unit is unstaffed, you can use the set secondary command, or set S. And what that does is when that master is disabled, its secondary is now redirected to something else other than what you have in the configuration. So I can go on master 3, set secondary for master 3, its new secondary is master 4 rather than the group 10. Oops. Set secondary 3, 4. So now, if master 3 is still enabled, there's nothing new happening. So if I can press the call in, the call in still goes. Oh, let's I have master 3 is disabled right now. Enable master 3 enabled. All right, let's try this again. So my master 3 is enabled. If I press the call in, nothing new happens. The station still calls into master 3. I can answer from master 3. I'm just going to pick up the telephone. But when the master 3 is disabled, it has a new secondary. Enable master 3 0. So now, so I've told the system that instead of going to central control, it's going to go to pod B when pod A is unstaffed. So now I press the button and it goes directly to master 4. So you can redirect temporarily where a station goes to, or where a secondary is set to by using that command. So that's one way of changing the operation on the fly. If I re-enable the master, it goes back to the original master. Intercom call request 3, and I'll answer it. So that's one way of doing a redirection, is using a set secondary. So that's useful for things like living unit redirection, or if you have something on the order like that. So there's lots of applications you can do for that. So that's one way of changing things on the fly. The other way that I kind of mentioned is, say for example, you have a unit that has 4 central control master stations. And during a really busy period of time, you might have master 1 handling the north wing of the building, master 2 handling the south wing of the building, master 3 handling the west wing of the building, and master 4 handling the east wing of the building. So lots, during really quiet times, you'll have master 3 handling all of the building. So how you can do that? So you can do that by the call-ins can go to a virtual master on your system. So you can always do all of your management yourself if you want to. So all of them will go to a virtual master in your station templates. All of them will point to your virtual master, and your control system will receive the call-ins, and you'll decide which touchscreens to show it on. That's always an option. You can have the intercom system handling the forwarding for you too. So you can automatically, so that will also handle master stations with the keypad display. So if the call-ins go to a virtual master, you won't see them on these masters. You won't be able to answer them because they're not going to be directed to these masters. So if you have keypad display style masters, or if you want the intercom system to do your management, we have a way to do that. and that command is called a set master. So in an application like that, so typical what I see on the user interfaces that our customers implement is the staff member walks up to their workstation, they have a graphical representation of the facility, they log in and they select which wings that they're going to log into. So the busy time of day, the staff of workstation 1 will log in and they pick the west wing. One person at unit 2 would log in and they pick the east wing. But during quiet times, there might be one staff member, he'll log in and he'll pick all the wings. Picking the wings on the touchscreen will send a set master command for stations in that wing. Now, I mentioned we have the ability to have a station group, which allows you to control multiple stations at once. So this is a great application for the set master, or for the grouping. So you would have all of the stations in West Wing would be in a station group. So you list all the stations in West Wing as a station group. So you have a station group number for the West Wing, you have a station group number for the East Wing, a station group number for the North Wing, a station group number for the South Wing. When they log in, they will use the set master command. So set M, which sets which master a station calls into when the call button is pressed. So you send a set master command. You give it the station number. So it could be a single station. So you can redirect a single station. But this type of application, you want to use the station group number. So redirect all of the stations in that wing. And then the second argument to the set M command is the master number to redirect them to. So if you say, for example, West Wing is group 199, if you send the command set M 199, that's the station group number, and 3, that will set all of those stations will now call into master 3 when the call button is pressed. So we'll go into only that one control station. So that is another way of redirecting things, is redirecting which master the call button goes to. And that could be a single station or it could be a group of stations, which is quite useful for this type of, some people call it task grouping, which I think is an appropriate name. So to do that, you use the set M command. So say, for example, I don't have a group defined, so I'm going to use a single station as an example here. So I'm going to have station number 401. Normally, station 401 calls into master 10. Actually, before I even do that, I'll go back to what we're using in the set secondary. If you need to set the secondary back to its defaults, you set it to 0. And now, if I disable master 3, enable master 3 0. If I disable master 3, now it goes to its usual place. Oops. Set secondary. Oh, sorry, I'm wrong. Is that you need to give it to the master number is supposed to go not 0. Let's go ahead. Answer that. All right. Okay. Finish. All right. Going to set master. So I'm going to redirect Intercom 401 to go only to master 4. Set master station 401 now goes to master 4. So now if I press that intercom button, it only goes to master 4 rather than master group 10. So you can use that, send those commands when you log in. You send the command to set M, that group number this master number. I changed this, the master now is calling into the group. Any questions? Don't see any hands up. So this is the basics of our system. You send commands to the system. Any activity on the system will be sent to you through that text interface. And for the most part, you're going to be using intercom call, intercom end or end call, page end, maybe a master call, and you'll be looking for the call request. You might be looking for audio level alarms, which is a level, and you can look through the reference in the interface guide, host interface specifications to see all the different other commands available. There's tons and tons. Where is my scroll bar?
So I do have one question. It's more of a curiosity,
Okay.
not particularly related. Do you ever have any issues with firewalls with these serial communications? Do you ever experience a problem where firewall on a network will shut down serial communication like this?
No, I can't say I've ever heard of a firewall preventing this. Now, firewalls. Now, so this is a simple single TCP socket. So it's very it's a single socket, and in most cases it's not going to the internet, so your firewall doesn't normally block it. But if you've got a very strict firewall, it's a single port, and it's very easy to let through a firewall. But I've never heard of a firewall affecting this, because you don't normally firewall your internal traffic. You only firewall your external traffic.
Right. Okay. Yeah, like I said, that was just curiosity.
Yeah. So I don't normally see that. Now, one thing I do mention when we were looking at using the file manager yesterday, and I'll make note of that now. We might as well. So when you're using the file manager and you connect up, it actually opens up two connections to the DCC. One is a standard text socket or text. One's a standard string. So normally there's not a problem with the, like when you originally do that, if your firewall may come up with a warning on it, but it normally doesn't, because it's a single text string to something within your network. So that doesn't normally get hit, but if you got, depending upon your firewall strictness. So it opens up a connection, and that text connection is to get a directory listing of what's on the system. So it gets you this directory listing, and when you click on a file, it tells you the size of the file, it tells you the checksum. So that text interface, so that single stream gets you that information, gets you the listing, and it gets you this checksum and size in the middle. So that normally doesn't get hit by a firewall. When you use the copy button, we use the standard FTP file transfer protocol to copy that file from the DCC to the PC, or vice versa if you're clicking and copy from the PC to the DCC. That transfer is done through file transfer protocol. That can get hit by your firewall because it's a fairly complicated mechanism. It's not a single port, and it's not always the same port. File transfer protocol is a little bit special. Your firewall FTP is a fairly standard protocol, so your firewall probably is going to handle it, but it's not a single port that goes through. There's a trigger port, and then there's additional ports that's used for the file transfer protocol. So it's a little more complicated, and a firewall will hit that. So if your firewall isn't configured to let FTP traffic between your PC and the DCC, that will happen. And what happens with that is when you click on, so you'll see the directory listing, works just fine. But when you click on the copy button, the window in the progress window in the start doesn't go anywhere. And then after a while, after a couple minutes, it'll time out. If you see that happening, it's probably your firewall is preventing that FTP traffic between your PC and the DXL system. So that's where I see a firewall get hit. Is that's if you're going to see a firewall problem, that's it right there. And typically, what that's caused by, normally when you're using most firewall programs, the first time you run a program, it'll ask you, do you want to let this program through? Sometimes, depending upon the program, it's a delayed response, so it might be showing up in a window in the back. So if you run the first DXL administrator the first time and the file manager the first time, see if you find that prompt. If you see that prompt, click it right away to say, yes, you want to have DXL administrator allow full permissions. Otherwise, if you don't answer that, it's sitting in the background, sometimes it'll time out and it'll deny file transfer permission. And whenever you try doing that, nothing happens. You'll get that long delay. So if you have that kind of problem, take a look at your firewall settings. If you can either uninstall and reinstall it and hopefully click on that prompt when it comes in, or you go into your firewall settings, you go look for the DXL administrator software and make sure you give it all permissions. So that's really the only firewall issue that I normally see. All right.
I did post a question in the chat.
Okay.
Regarding the stat command.
In the chat, okay. Mark, will a stat command send response to the master registers? No, on a PLC, I'm going to go over the PLC. So the PLC mechanism, if you are using, there's two methods for particularly getting responses back on the PLCs. Is the first method, which is the only method available on DXI, works exactly the same as what I just discussed on this text interface. So the first method is a message-based system. So instead of sending a text command with up to 4 arguments, you have a block of 5 registers with the command in the first register and the parameters in the following 4 registers. So when you send a command such as a intercom call would be command 7. The master numbers in the second register, the station numbers in the third register, and you fill up the rest with zeros. When the system acts on that, you'll have a response set of registers that are within your sent to your system. So the response would come back as a block of 5 registers with, for example, if you sent an intercom call, you'll get an intercom call, a 7 in the first register, the master number that successfully completed the call in the second one, the station in the third register. So you'll have it in the same format as the text, other than each block is a number. So it's the command is a number, but otherwise the same thing. You have a command followed by up to 4 arguments. A stat command, if you're using that kind of a message-based response, so you send a message, you receive a message back with the 5 responses, 5 registers, then yes, a stat command will send you all activity. So it'll send you the first one, it'll wait for you to process it, it'll send you the second one, it'll wait for you to process it, it'll send you the third one, wait for you to process it. So yes, a stat command and an all stat command will work if you're using the message-based PLC mechanism. The stat command is a really good way to make sure that your system can handle all messages. Now, I mentioned previously that if the intercom system will send, say, for example, a call request, will send it once. If you miss it, then the intercom system thinks there's a call request, you think there's no call request, and there's a problem. It's not on the screen, the staff isn't gonna, they're not gonna answer it because it's not on the screen. So now there's someone sitting at that door waiting for a response and nothing's happening because It's in the intercom system, but it's not in your control system. One very good way of making sure that you can process that is this stat command, because what it will do is it will send you responses as soon as fast as you can process them. So this is a very good way to make sure that you can process all the responses. Is what you do is you go around. Do I have my window still open? That's the loop. Okay. So what you do is you go around and so first of all, you go in and you either disconnect your PLC system or you clear all your registers. You clear all the calling status of the registers. Then you go around and you press intercom call buttons on some of your intercom call stations. So I'm gonna disable master 3 right now. So I'm going to go and pretend that I disconnected. Well, I can actually just disconnect. So I'm going to go through and I'm going to go and press all 15 active intercoms going to my living unit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That one's not working. Now, a couple of them that aren't working here. Call buttons. Oh yeah, that's because I mentioned the screens yesterday. These ones don't have the screens. So I have 12 intercoms calling in. I know which 12 they are. Now I can go in and I can reconnect to the system and I send the stat command. So I can resend the stat command and you can take it, so the system will send you all the activity for that master as if that happened right now. Bang, 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 bang. There's all my call requests. So now, if your touchscreen system was active, you want to go and make sure you look at your screens and make sure you got all the call-ins that you pressed. So this is a very good way of determining. Yes. I had a question? Or maybe not. Okay. So this is a very good way of checking your software to make sure your software can handle all the activity coming in, that you're not missing something.
Is the same, I believe the same thing goes for the PLC. If you're peer-to-peer and you send a single stat request to anything, it'll actually update everything that is peer-to-peer to that PLC. Is that correct?
Yes. Yeah, whether it's peer-to-peer or polled, it's the same thing. It will send all the responses as if they happen right now. Now, peer-to-peer, so a polled mechanism, I'll get into that after the break. So we're going to have a break right away here, and we're going to go into the PLC part. But yeah, so there's two methods of getting information from the DXL system. Is you can either read registers from the DXL system and copy it and then act on them, or the DXL system can update you as activity happens. And for a polled method, when you read a register, the intercom system is going to assume that you process it before you read the next one. So you read a register, it'll make the next register available. When you read the next register, that's going to it's going to make the next one available. So it's always when you read it is when it will put the next command in. You read it, it puts the next command in until you've cleared your backlog. The peer-to-peer method typically used for Omron was when the DXL system has a new update, so one call request. So in this, there's a whole bunch of call requests. There'll be 12 call requests going all at once, or not at once. It'll send the first call request into your PLC. Your PLC will operate on it, and there's a mechanism called a handshake mechanism. So when your PLC responds to it, acts on it, it sends the intercom system a handshake saying that, okay, send me the next one. the intercom system will send you the next one. You'll process it. You'll send a handshake. So it'll be one at a time, but in control of your system as to when the next one goes out. So it will queue up all of these station call requests ready to go out. And then as you read them and process them, it will send you the next one until it clears out the queue. Any other questions regarding this? So we're going to have a break, and the next part I'm going to go over is I'm going to go over how to do this with the PLC or with a PLC interface. So the PLC interface is just this with numbers, but there is also an easy mechanism that you can have. So in this case, it tells you the intercom number and the master number, and you have to set your own internal status to show that intercom is calling in, or that intercom is in a call. With a PLC-based interface, the DXL system can have a register per intercom station that says what this intercom station is currently doing. Is it calling in? Is it in a call? So that's a simplified mechanism you can use that I'm going to go over. And then we're going to go as an example using Wonderware InTouch to create a touchscreen with this system. First of all, one thing I do is I go and clear all these comments. All right, so we're gonna go for a 15-minute break. We'll be back in 15 minutes and we'll continue on with the PLC. The PLC protocols and the Wonderware interface. All right, so this morning we went over the host interfacing, a little bit of information about hosts, and one master can only be controlled by one host, but one host can control multiple masters. So, and we went over the commands. So I'm going to go over the PLC commands, which is basically the same thing as what we looked at before, but rather than having a text with a text command followed by up to 4 different parameters, now it's going to be a block of 4 numeric registers, which has a command number in the first register, and then the rest of the parameters in registers 2, 3, and 4. So first of all, we'll start with my little notepad here. So when you're sending commands to the intercom system, there will be a set of 5 registers. So a PLC is a programmable logic controller, and basically from the point of view of a control system, it has a number of variables or registers, or basically numbers. That's stored in it, and then it will, it can do things with that. It's like the register may be the relay control for a solenoid to open the door. It may be a sensor that measures that reads your door, whether the door is open, whether it's closed, whether it's locked, whether it's unlocked. So those are all stored and controlled by basically sending and receiving numbers from your control system to your PLC. That the PLC will then use that to open the door, close the door, check to see if the door status is open or closed, if the intercom is calling in, whatever. So it's just a series of numbers within this PLC computer that you can write to and read from. And so from the purposes of what we outlined this morning is, rather than sending a text string to the intercom system and receiving a text string in response, if you're treating this like if you're simulating or emulating a PLC, the intercom system will have a block of numbers, and instead of sending you a text string with 5 of a command, a text command, and 5 parameters, it will send you a number for the command and a number for the first parameter and a number for the second parameter. So it'll be a block of 5 numbers. So both sending a command to the intercom system to, for example, make a call, make a intercom call, that there'd be within the intercom system, there'd be a block of 5 numbers that we would write. The first number would be the command, the second number would be the master station in the case of a call request, the third number would be the intercom number. Likewise, when intercom sends you a response back, it'll send you a response as a block of 5 numbers, a command, and then up to 4 parameters. So the first thing with regards to sending a command, normally when you send a text string, you send a text string and then you hit enter and enter all. Okay, I've entered all of my command. Well, there's no easy way to, well, depending upon how you transfer data. In most cases, the data is transferred to and from the PLC as a block. So if you write a block of 5 registers, most cases, even though that your programming will write them one at a time, most cases your driver software will condense them into, well, you've made 5 little changes, but what it'll do is it'll wait for a little bit and it'll only send the changes once it knows you're not making any more changes. So in most cases, it will send that as one block in one network message. So if that's the case, it's not a problem. You're sending the whole command at once. Just like when you press enter on a text command, the enter means that you've entered all of your command and now you can process the whole command. But sometimes with some PLCs, they only read and write one thing at a time. So for example, I'm just going to go back in the back of this text file. So this example is if you're doing an intercom call from a master to a station. So the block of 5 registers would be 7, which corresponds to intercom call, and then there'd be a number, which is the master number. There'd be a number which is the station number, and then it fills in the rest of the 5 block of registers with zeros. And so if you send it all 5 registers at once, then everything is available. But I'll have an example here. So I'm going to go at the very bottom. So say, to start with, all the registers are zeros. Okay, no problem. There's no activity. Now, if you send them all 5 at the same time, 7, say I'm going connecting master 1 to station 101. They're all at one time. It's not a problem. So I'm connecting. So I receive this. I get that message all at once. I receive the command. Okay, so the command is connect master 1 to station 101. But say we started from 0 again. And it only updates one at a time. So if it updates the first register and not the others, well, what you see is 7 followed by 4 zeros. So the intercom system will act on that and go, okay, connect master 0 to station 0. Nothing happens because there's no master 0, there's no station 0. And then it updates the second register. That's also invalid. And then it updates the third register. And then that finally becomes a valid register. Now, how our system handles when the process of command is it processes the command when the first register changes. So this line right here that I'm highlighting, the first register changed from a 0 to a 7, or it was written. The value was written. Doesn't even have to be changed. It could be writing a 0 and could have a 7 previously and write a 7, but the system knows that you wrote something in. Even if it's the same value in, it will act on it because you wrote something into that register. So when this first register is written into, the 7 was written into, it's going to act on whatever it sees on the rest of the command. But the command is incomplete yet. You haven't filled in the rest of the registers. So this command wouldn't be acted on, wouldn't work properly because the command wasn't filled in when that first register is updated. Later on, say if you want to, so this is the intent, you wanted to go update 7.1.101, so it doesn't act on the command because it's all 0. So ultimately you'll write all the values in. But it hasn't connected to anything, it's still connected to nothing. right, so say you want to send the next command. Say you want to connect to intercom 401. So the command that you want to connect to, the command you want to send is 7114010. So that's the command that you want to send. But if you write it one at a time, starting with the first register, what happens is you're going to write a 7, while keeping the rest the same as above. Which, look at it, what it actually will act on, it'll act on 71101. So because you updated only the first register, you're in the process of updating the rest, it sees this first register change and it will connect to intercom 101, which was the previous. So it will be kind of one step behind because it's acting on the last set of remaining registers. So that's just something to note. So our system operates when the first register is written. If you write it as a block, which is going to happen in almost all cases, then you don't have a problem. You just do things logically, do things normally, and things will work. But if, for whatever reason, your PLC or your data acquisition server or whatever driver you're using, if it does it only one at a time, then make sure you write the first register last. Doesn't matter the order for the rest of them. So you could write register 2, 3, 4, 5, and then 1. Or you can go 5, 4, 3, 2, and then 1. As long as the first register is written to last, then the rest of the command, the rest of the arguments will be in place by the time the command gets processed. So just a note on that, almost all drivers, all DA servers that I'm aware of will do it as a single block. If you're using a PLC to communicate PLC to PLC, if you use a block write command, it should work. But sometimes you might not have an option for a block write. So if you do single registers, write the first register, the command register last. So that's one note on that. The other note, so this is on commands that you send to the intercom system. So you're always going to write a value into the intercom system's control register on the intercom system PLC. So you're always going to be doing a write into the DXL system's IP address. When the intercom system has a new message for you, there are two ways to accomplish this. One is called pulled. So all the registers are still within the DXL system. And what your system does is it will use the DXL system's IP address. It will read the registers from the DXL system. It'll make a local copy, so it'll copy them to your system, and then you'll have an internal data value with those registers. But there's the polling is it's going to periodically read those registers from the intercom system, copy them internally, and then act on them. Read them from the intercom system, act on them. So that's a polled mechanism. And what typically happens is that you set a scanning rate. So you might say 5 times a second or 10 times a second that you're going to have a polling rate. It's going to read all the registers from the DXL system. It's to copy it to a local copy, and then you're going to look to see if anything has changed on it. So in the case of these master status registers, whenever the system has activity on it, you're going to read this block of 5 registers, or maybe a whole bunch of blocks of 5 registers, a whole bunch of registers. But this particular case, you're looking at activity changes in this block of 5 representing the status, the messages going to that specific master. You're going to read it on a polled interval. So a lot of cases, that polling interval is something out of your control. You set up how often it does it, but you're not notified when things change. So you're going to have a polling interval at when things are new information is pulled into your system, and your logic is going to read your internal registers. You have a polling on the server software, and you have your own internal processing on your side of things. And typically, you have your own processing. Depends. I'll go through on the Wonderware, so what that looks like. But there's a separate interval for how often it reads the registers versus how often it processes the registers. And you want to make sure to avoid losing these messages, particularly with regards to these status type messages. Now, the simple way doesn't need to use this, but if you're using a DXI driver or a DXI only have the ability, you sent it a message with the 5 command and parameters, and you received a message with the parameters and you had to interpret it. If you're using that mechanism, you want to make sure that you process messages more often, or at least as often as the scanning from your server, that it reads it from the server. If you are only able to process 1 message a second, but the scanning is set to send you 2 messages per second, well, then you might not, it'll send you a message. So if you got 2 intercoms that are happening at the same time, your scanning reads the first one, and then maybe your logic starts processing the first one, and then the scanning reads the second one, and you're still processing the second one. So now you missed that second call-in. So you want to make sure that your processing logic operates as fast as or faster than your scanning logic. So if you can only process 5 a second, make sure that it's scanning 5 a second or less. Any questions? So that's the poll method. The peer-to-peer method is that the poll method is every time the scanner reads a message, that assumes the intercom system has you processed it. So that's why that processing has to be as often or more often than the scanning, because every time you read a message from the intercom system, it's going to assume that you're going to be processing that message. It'll make the next one available. You read it again, it's going to then put the next one on the queue. So as you read it, it'll make the next one available. So if you can't process them fast enough, or as fast as what you're reading, then you could be missing messages, because the intercom system will, as soon as you read it, it'll give you the next one. The peer-to-peer mechanism, rather than your system scanning the DXL system, reading the messages, copying them internally, the DXL system, if it has a new message, it will write it into your system. So you'll get an automatic update into your system. Now, again, you have to have some sort of time to process it. We don't want to send you a message. You don't have time to process it. We'll send you the next one. You don't have time to process it, so that you will also miss messages that way. But you don't have control over when the intercom system writes into you. So what we have in that method, with the peer-to-peer method, is we have what's called a handshake registry. So the intercom system will write the updates into your system. When your logic has processed it, you would send the response back to the intercom system saying, I processed it, give me the next one. We call that a handshake. So the intercom system will write the updates into your system. It'll wait. If there's another value, if there's another update waiting, it'll wait. Once your system has processed it, it will send a handshake. It writes a value into a handshake register on the DXL system. The act of writing any value, doesn't matter what the value is, the act of writing any value into that handshake register on the DXL system will tell the DXL to send you any new update. So if there's another message waiting to be sent, it can be sent right away. So send a handshake every time you process a message that you receive, and the DXL system will send you the next one. So that's the 2 mechanisms. The peer-to-peer is a little simpler to do, but there's a lot of network traffic because it's always copying data to and from the DXL system. The poll, that's the poll. The peer-to-peer is very efficient on bandwidth. It will only send you an update when there's an update, but you do have to respond back that, yes, I've gotten that update, send me the next one. So the DXI compatible, or the hard mechanism for what I call the hard method for PLCs, is doing just what we did with the text interface. The intercom system sends you a message, you process it internally, and if it's a peer-to-peer, you'll send the response back saying, yeah, I got it, send me the next one. But it works functionally the same as what we want with the text interface. It'll send you commands, and you send it commands. So I'm going to go into the configuration here, and I'm going to change to my PLC interface. Whoops. Now, while I'm doing this, so I'm using the same version I used to create with this, but I'm going to just show you something else that you may see. So this is a DXL administrator that is different than what I used to create the configuration with. Oh, no, that one is the same one. It's updated that icon. Okay, I'm going to go on. Yeah, it's a really old one, but that's a good example. So I have a really old version of DXL Administrator here. So I'm going to go and open up my project. And it gives me a warning. It says you are opening a configuration that is not supported by the current version. And so if you have a older DXL administrator trying to open up a new configuration, you're not able to edit it, modify it. You can look at it, but you can't make any changes to it. So if you come up with that prompt, if you have an older one if you have an older DXL administrator and opening up a configuration created with a new one, you're not able to edit it, and you only get a prompt to say you look at it, continue anyways or not. If you have a configuration created with an older DXL administrator and you use a newer DXL administrator, it'll tell you it's a different version, it's older, and it'll offer you to upgrade it if you want. So you can click on upgrade and then you can modify it. So you can always use a newer DXL administrator to look at and modify an older configuration, but you may need to download a newer administrator if you have a newer configuration. To find out if you want to use the same, if you have a configuration and you don't know what version of DXL administrator was used to create it, and you don't want to make changes to the site because there's something on the jail site, and you can always use the latest DXL administrator, update it, and it will always work. So that's not a problem, but if you want to you don't want to mess with the site, you don't want to make their configuration newer than what it was, then if you want to find out what version that you need, you open up the configuration, you go File, Properties, and it will give you a version number. It says a schema version, so that's the version number of the configuration. This doesn't correspond to the DXL administrator version, but it corresponds to essentially it's the database version. It's the version of the configuration. That's really only useful for our engineers or our programmers. This is the version of configuration that you have. But what you can do to make that kind of more readable, more human readable, is you go into the README file for the DXL administrator. So if I'm going into where I've installed my DXL administrator, and there'll be a release notes.txt file. So I can click on the release notes, and it brings up a text editor. And you can search for that schema file. So look for 1.5.30. So it says, okay, so it's actually this is the latest version. So 1.5.30. The DXL administrator used to create that is 1.6.4b1. So now I can download 1.6.4b1 and not have it won't give you a warning prompt because you're using the same version of the DXL administrator. So that's matching up the schema version with on the DXL administrator. So as you different versions will show you what schema was used. So this one, if it was 1528, you'd be using DXL administrator 162. All right, just diverging here, going back to my DXL administrator, the same version. So when you're using a PLC interface, I don't know what, I can't remember what changes I made to this. So, oh wait, I didn't make changes. Okay, I'm gonna go to my host ports. So first thing I do is my example, I'm gonna make it as a Modbus. I'm quite familiar with Modbus, not as familiar with Omron, so I'm gonna use Modbus. My connection is going to be still a Ethernet connection, but now I'm going to be using a register message. I'm going to be using Modbus TCP/IP. The choice being a Modbus, Omron, and a variation of Modbus called Simplicity for the Simplicity HMI software. Modbus, the difference is Modbus doesn't normally do peer-to-peer. And Omron can read and write, PLCs can read and write registers into their own internal registers. Modbus, particularly for the data acquisition servers, a lot of them, they don't allow, the data acquisition server doesn't allow you to write values into it. It only does reads and writes itself. So Modbus normally is peer-to-peer only, polled only. Omron is normally peer-to-peer only. Simplicity is a variation of Modbus that you can write values, so it's peer-to-peer Modbus for the Simplicity software. So I'm going to use Modbus. With Modbus and Omron, all of the values within the PLC are given a register number. That's the particular data portion that you're going to read or write from. In the case of Modbus, the registers are typically nomenclature for that is normally you have either the block of registers from 40,000 on, 40,000 to 40,000, 49999 would be your integer values you can read and write to the PLC. Or for bigger PLCs, they may have more registers, so you can define it to have your registers start with 400,000, which gives you a lot of registers you can read and write. So the digits tells you how many digits after the 4 that you're going to be using. So I'm going to use I believe my example uses the 400,000 range. Sorry, the 40,000 range. If I believe correctly, can look at my example here. It's the wrong example. That one's example. So yes, I'm going to be using the 4 plus 4 digits. When I change the protocol, the Modbus protocol normally uses port 502. So when I do this, I'm going to get a prompt that says it changes. It's going to change the connection to a port, change it to port 502. The next step is, so I've previously assigned which masters this host port can control. So for simplicity's sake, I'm only going to do my touchscreen for master number 1. So I'm going to assign all of them to my host, but really I'm only going to be editing one. So this edit master registers is going to tell me I'm going to specify that block, the starting address of that block of 5 registers when I'm writing a command to the intercom system, and a block of registers when I'm reading a command from the intercom system. Before I start that, I'm going to go into this registers, and I'm going to specify whether I'm going to be using the peer-to-peer mechanism where the intercom system writes a value into your PLC or into your control system when it updates, or whether you're going to be scanning or polling it. So my example is going to be using polled mode. So I'm going to go into the polled mode. I'm going to select polled mode over here. I'm going to go back to the Masters tab. I'm going to be, the example is going to be showing the master control master number 1. So I'm going to go click on edit master registers. So it's going to show me the register number for that block of 5 registers. So you can see over here the command registers. So if you're writing a command into the system, you're going to write a block of 5 registers into the DXL system. When the DXL system has a status update available, it will write a block of registers. It'll have a block of 5 registers available that you read on your scanning interval. So you're going to assign, for every master, you're going to assign a command register block, which is 5 registers long. And optionally, if you're using the message-based one, you'll have a status register block, which is 5 messages long. I'm going to do an easier way to do things. So when you're sending a command to the intercom system, you still need to send a block of 5 registers. But I'm going to have each individual intercom will have its own separate register to indicate the current activity on that station. So I'm going to have, instead of having, whenever a station call request gets pressed, we'll send a message that says, with a block containing a call request, the master number, the station number, and then you'd have to process that. You can do that here, but I'm not going to go over that. That's harder to do, a little harder to set up. The easier way to do things is that you can have an intercom per intercom station that already has a status in intercom station. Your system will be automatically in your system. It's already processed, and you can use those values directly to to see whether the intercom is calling in, whether the intercom is in a call. I'll get to that shortly, but what we have to do is we have to assign a register number for every value that we're going to be using in the system. So I'm going to be using 5 registers to send a command to. So I'm going to put a register number in that 40,000 command register space that I'm going to assign register values to the 5 block of registers going to the master. I'm going to have a single register representing the status of each station. So each station will have a single register representing whether that station is calling in or not. And then I'm going to create a bunch of register blocks that are going to represent values in the intercom system. And I'll explain them as we use them in the control software. So I've got this chart. The example I'm using here is App 201, which is the Wonderware host interface example. And the first part of it, or this part that I'm looking at right now, is I'm going to set up registers for that block of 5 command registers to send the command to the intercom system. I'm going to have some registers that represent the master status, whether it's connected or not, and what it's connected to. I'm going to have a register for each intercom station. I'm going to have a register that represents its status, whether it's calling in, whether it's whether it's connected, whether it's listening to music, whether it has a fault. That's all part of this status register. So I'm going to create all these registers in the intercom system. So I'm going to start with the command register is 40,001, and it's 5 registers long, so it's going to be 40,001 to 40,005. This Q register is like the intercom master station. I'll just put that on here. Like the intercom master station, if I have multiple stations calling in, you'll see on the display the top line on there, intercom, the first intercom I pressed, they're all the same priority. So that's the first one pressed is intercom 101. The second line on the screen shows that intercom 401 is also queued up. So you can also reproduce this type of information on your touchscreen with this queue register. So the intercom system can give you a list of, in this my example, I'm gonna have the top 5 calls are going to be showing. You can show them on your screen with this queue, so that the queue are in pairs. So this has 10 registers defined. So the first 2 registers represent what is calling in. So this is an intercom calling in, and the number of the intercom calling in. The 3rd and 4th is the intercom calling in, and the type of call in, and the intercom calling in for the second one. 5 and 6 is the 3rd line. 7 and 8 is the 4th line, etc. So you can see a list of the top calls as to what is calling in, whether it's a master or a station or an audio level alarm call, and then the intercom number or master number that's doing the call in. So that's what these queue registers are for. So I'm going to enter these number values. So your programmer will have to determine what register values you want to use for each of these pieces of information. So I'm going to have the command register, which is 5 registers starting at 40,001. So I click on OK on this, apply changes, OK. I'm going to go, the other registers are listed under the status registers section. So master number 1, I'm going to have 2 sets of registers indicating what is connected to and the number of the thing is connected to. So that's the connection status register. So that is 40,006 and 40,007. And again, that's the length of 2, so the 40,007 is already implied. I have I didn't put the queue registers in there. So go back to the master, apply changes, go back to the masters. So the queue register starts at 40,011, and it's 10 registers long. 40,011, and there's 5 entries on the queue, which is 10 registers long. And then for each station, I'm going to have a status register that represents the station status. Status registers. Station. And these ones are 40,021. 4,021. Two. And yes, I have been asked this before. Isn't there an easier way to duplicate this, to add, to not have to type all these in? And our programmers say no. So this is the complicated part. 24. 4,025. Now, that's not quite true. We have no automated way within our system to do that. I've created some scripts with something called AutoHotkey, which basically you create a spreadsheet with the register numbers you want, the station number you want, the register numbers you want, and it will go in and it will basically go to your Excel spreadsheet. It'll copy the number. It'll go over to here. It'll change the station. It'll click on this field. It'll type that number in from your spreadsheet. So it can automated do that in, but it's not not built in within the system. So this is probably the most tedious part of this interface, is just going in and you typing in all these station addresses. And I brought that up with engineering and into the programming, and they just thought it was too difficult to do. So anyway, so you set up all those numbers. So I've created the command register block, that's the probably most important thing. I've created the alarm block, and then I've gone and created status registers for the master station connection status and for the intercom station connection statuses. If I had any page zones, I would probably assign a register for each page zone, but I don't have any page zones. Before I do that, I need to make sure, stop these beepings. All right, so that's the configuration part in the DXL administrator. So now I'm going to load this on the system. Actually, this is a fairly major change, so I'm going to make a bigger version update. And I call this one 1.1.0. That's changed from a text interface to a Modbus interface. All right, I'm going to use File Manager, load it on the system. You'll notice you can have multiple copies loaded on the system. So if you do need to revert back, you can simply just click it and click on the activate. Once you no longer need it, I no longer need this one, so I can delete it. It tells me how much size I've got on my system, so I still have lots of space on it. But I'm just going to delete it because I'm never going to need to go back. And it's still on my PC too. So copy, wait for it to copy over, click on it, click on activate. As soon as I find out where my cursor went to. Do you guys see just the Harding logo on your screen?
Correct, that's all we see.
Why is my... Oh, I know why. For some reason I lost that window. All right, there we go. All right, so and I lost my, here we go, there's my. Okay, so I want to activate my configuration. So while I'm doing that, I'm going to be using Wonderware InTouch. I have a really old version, but it works and we paid for it. So it's so old it doesn't run under Windows 10 and 11 anymore. So I have a VirtualBox with Windows XP installed. So the first step is I'm going to, in my control software, I'm going to do whatever's necessary to add a PLC to my system. So with the Wonderware drivers I have, this is done in a software package called System Management Console. So I'm going to open that up. So in the Data Acquisition Server Manager, I'm going to open it up. Configuration. So these are all the PLCs that I've previously created. So I'm going to reuse one of my existing ones. So you would create a PLC. So you would normally go and you would go. So you normally go this way. You would go add a PLC, add a MicroComm PLC, add a Modbus PLC object. And then it will come to the rest of these parameters. So rather than having to do that, I'm going to use one of my previously created ones. Let's see this one here. What's this one say? So I'm just going to temporarily change this one. So I'm going to use, my system was set to 96, and I already had a PLC on 96, so I just changed that. So I'm going to go to, and I just lost my mouse pointer again. There it is. So I'm going to go to this one. I'm going to say this is going to be my 96. So that's the 96 is the one that I just created, the DXL system. Okay, it needs to be restarted. So I've created a MicroComm PLC, and one of the things it's going to ask you is for the address of your PLC. So that's my address of my DCC. It's going to ask you for the port number. So the default MicroComm port, Modbus port number is 502. So this matches the 502 I've created in the configuration. This register size says how many digits is the register address. So I'm using the 4 followed by 4 more digits. So it's 5 total digits. So it's 5 digits here. So it's a 40,000 range as opposed to the 400,000 range. So that defines the PLC. And then you define, these are the names. These are how you would access the registers within this PLC by using these unique names. So I've created 3 access names representing the different, how often that they are scanned. So each of these will be scanned at a different rate. You could do this with just a single range. If you want to do it that way, you can do it that way. But I've done this to kind of outline that you can do scans at different rates by having different access names. So the first thing I have here, so that probably I'll start with this demo write. So any values I'm going to write into the DXL system will use this when you define the variable or register or tag in the Wonderware system. You define what's the PLC, what's the access to the PLC, how do I contact this PLC, and it's going to be given this unique name. So this name will be scanned at 0 seconds or 0 milliseconds. So it means it will never read these back. It's write only. You're going to write these values into the Intercom system. You're not going to bother reading them back because the Intercom system isn't ever going to change them. So you don't need to read them back. So you can reduce the amount of scanning you need by saying, well, I don't need to ever read these back. These are write only values. So I have some write only values that go into the Intercom system. I'm going to have registers that I want to read and get information about are going to have this read access name, and they're going to be scanned every 500 milliseconds. So every half a second, it will read these values back from the system. And this queue is that call queue, just like what's on the master station screens. You can see the list of top calls in the queue. You don't need to update that very often because the user isn't going to look at that 10 times a second. They're going to glance at it and say, okay, these are the ones that are there. So I'm going to have them update every 1,000 milliseconds, or every second those will update. So I've created those 3 access names. So I'll need to know these names when I go into Wonderware. So the setup you need to do to define a PLC in your software. Use whatever you need to do to define your PLC. So you make a Modbus PLC or an on-run PLC if you're using fins, and do whatever configuration you need for configuring the IP address of it. Configure the names that you're going to access it from. So that's the IP address, that's the port number, and that's the names I'm going to need to access it with. So I'm going to go to my drivers, and I'm going to start my driver. Made some changes, so I'm going to shut it down, and I'm going to restart it. Now, one thing on this particular example, you can get an indication as to whether or not you're. Actually, I don't have a touchscreen that's reading them yet. That was that one. Yeah. Yeah, I don't have anything using it yet. So, all right. So I've defined my PLC interface. Let's go back to this. So now is the fun part, where you go into your touchscreen server software. So I'm using InTouch. I'm going to create a new application. New. Next. I'm going to start it up. So now, just like on the DXL side, I had to give registers to all of my components, all of my register values. I'm going to have to do the same thing. I have to associate the register number, so that's under the tag names. I go new tag. So I'm going to, where is my problem with this virtual machine is my cursor gets lost. There it is. It's coming down now. Okay, so I'm going to create a access. Okay, tag name. So I'm going to create a tag. So I'm going to call it so these are the tag names. I'm going to call it master 1 command 1. It's going to be 40,001. It's going to be an IO integer. And this is where I would create those 3 topics. So first of all, application name is going to be the server I'm using, which is Modbus DA. No. Let's scroll down my cheat sheet here. Okay, there's the commands. Mod DA server Modbus TCP. DXL demo right. DXL demo right. DA server Modbus TCP. DA server Modbus TCP DXL demo right. So this needs to match what's on the on the PLC configuration. EXL demo, right. And I advise all items, so it's even, whether it's on the screen or not, I want to update these data values. So that's the where I'm getting it from, and the register value is 40,001. Register 40,001 from this access. Save it. I'm going to create command 2 at 40,002, so I'm going to go new. It automatically updates that, automatically updates that. Good, good. 3 at 40,003. 4 at 40,004. And 5 at 40,005. Okay, so that got those covered. Q1 at 40,011. Yeah, 40,000. So I'm going to now, this is going to be the read for the queue. So I'm going to change the access name. I'm going to add DXL demo queue. Same server, DA server, Modbus TCP. DXL demo queue. So this is going to only read once a second rather than, this is going to read once a second. I want to always see it. Actually, I don't necessarily need to do that because you're never going to, but anyways, I'm going to do it that way. DXL demo queue. So it's going to come from that one. It's going to be, okay, good. And it's going to be 40,011. Save it. Next one. Q2 at 40,012. Save it. So I'm going to do up to Q10, up to 40,020. Let's see, new 13, good. 14, good. 15, 16, 17, 18, 19. And 20. Okay, so I've created those 10 queue registers, and I'm going to create just a couple more. So master 1, I believe I call it status 1. Master 1, M1 status 1 and M1 status 2. M1 status 1. And that one was on register 40006. 40006. Oops, too many zeros. And this is going to be a new access name, which could be read twice a second or 500 millisecond intervals. So I'm going to add a new one. DXL demo read DA server Modbus TCP. Always update it. Now, one note about this prompt here, there was protocol to use. My older version of Wonderware needs to use this DDE protocol. If you have a newer version of Wonderware, this does not work. You will need to use SweetLink. I had a couple customers go over my example and they go, it doesn't work. And then it took us, both of us were scratching our heads, and they had called up their rep and yeah, so my older Wonderware needs DDE, your newer Wonderware needs SweetLink. All right, so I close that. So what's at 40,006 and 7. Save it. status 2 on 40,007, good. And then the last thing I have is each of my stations will have their station status register starting at 40,021. Or 4,000, yeah, 40,021. New. Station 1 status. 40021. And again, it's the same topic as the read topic, read twice a second or 500 millisecond intervals. Make sure that's what I set it up for. S1 status 21. One is 22. 23, 24, 25. This is all the administrivia. Now that we're almost done here, I mentioned yesterday there was a system health status. So I'm going to create a tag for the system health status. And tag name. So this is a special, instead of having a register value, it's going to be a special value, which is the coming from the driver. So I'm going to call it connection status. Let's see if I have that in here. Oh, con status, okay, comm status. And it is going to be a special value that instead of a register number, it's going to be $sys $status. $sys $status. So you have to look at your DA server, your driver, to find out if it has an appropriate value that you can use to check the communication status to the system, to that PLC. Just gonna verify this is the correct thing. COM status SYS capital status. Yep. All right, so that's the trivia part of things. Now, it's actually quite easy. So I'm going to create a window. And I say this is the main jail. Stretch it out a little bit. I'm going to create an example intercom. So I use my tools. Okay, I got that there. Tiny little toolbar off on the right. So I'm making it a little stylized. I'm excessive compulsive. I want to make it exactly square. I put a little intercom call button in the corner. Move it around a little bit. All right, so I got a little intercom icon. I'm going to make it an integrated icon. Now I can drag it around. So there's my intercom. I'll make a bunch of them, but I'm going to do only one right now. So I'm going to have an intercom in my jail. I'm going to make a little button over here. I'll make another button while I'm at it. So this is going to be, I'm going to have a button to end my call. Actually, no, I'll make this one the end of the call button. So I'm going to change the text, substitute text. I'm going to make this one, I'm going to use this one a little later, but I'm going to do it now, and I'm going to make this a push to talk button. And now I'm going to add some debugging information that you don't normally need, but I'm going to use this to show you what is happening with the system. So I'm going to put a numeric value above my intercom to show you. I've told you that each intercom is going to have a register associated with which shows you the status of that intercom. So I'm going to make this display that number what the status of the intercom is. So I'm going to double click it. I'm going to click on value display analog, and I'm going to display the value of S1 status. That's that value that represents status of that intercom. I'm going to put two little numbers besides my call button, my end call button. I'll move it around, put it over there. I'm going to make that display the value M1 status 1. I'm going to duplicate this, move it around. This one's going to be M1 status 2. And for good measure, I'm going to put another. So these represent the status of the master. And I'm going to add another 5 debugging registers over in the bottom somewheres that are going to be the last command that you sent to that master. So number sign. And I lost my cursor again. And this one is master 1 command 1. I'm going to duplicate this. Oops. Make it all nice and pretty. So these are going to represent that command I send the intercom system. Command 1, command 2, command 3, command 4, and command 5. And I'm going to do one more troubleshooting icon. So I have a big LED off in the corner. That's going to represent whether I'm communicating with the intercom system or not. So I'm going to have that one is going to be a fill color. So I'm going to fill this circle with. So I'm going to make it, if it's communicating, it's going to be green. I'll make it a brighter green. And if I'm not communicating, it's going to be red. And the value is if it's 1, then it's communicating with the system. All right, so there's my initial touchscreen. Can't really do too much with it right now. Actually, well, no, I'll do something with it right now. First of all, I'll have it, if I click this button, I want to send the end call command. So I double that and I click on action. when I press this button, I want to change the values of the registers within the DXL system. So I want to say master 1, command 1. I'm going to set that to 10. So 10 is the ENDC or end call function. So that ends whatever this master is connected to. Master 2, command, master 1, command. So I want to make the second register the master number. So that's master 1. Master 1, command 3. So the only thing I need is an end call on the master number. So that the rest of the arguments I can fill in with zeros. Master 1, command 5 equals 0. So when I click that button, it's going to send in that block of 5 registers. Command is going to be 10. Register 1 is 10. 2 is 1. So 10, 1, 0, 0, 0. So it's going to do an end call to end whatever is connected to master 1. All right, so this is going to be very simple. I can't do everything with this right now, but I'll show you. This is the first pass at my system. So I'm going to go and do the runtime. So let's get a run. So the first thing I see is I have my connection status is green. Well, that's good. That means that I am communicating with the DXL system. I'm not sure how long this takes, but I will go and disconnect the Ethernet from it. And a few seconds later, you should see an update indicating that I've lost connection to the DCC. There we go. So now I've lost connection to the DCC. The connection status turns red. So as a programmer, that is the first thing I want to look for, is make sure I've got communication to and from the system. That's my top priority. Make sure, because if you write values and you get nothing, if you have no activity, then is it because you're doing something wrong? Is it because there's no connection? So if you have that option, that's the first thing I look at. All right, so that's good. Good. Master 1 is my master that has a keypad display. So I will go and show that to you right now. Off in the corner of the screen. So now I can press one of my intercoms. Intercom number 1. I press the call-in button for intercom number 1. You'll see the display update. So intercom number 1 is calling in. You'll see this number that I've associated with the intercom is changed from a 0 to a 4. And that's where the value of that intercom station, so that's the intercom station number that's changing. And what does that mean? So that is a bitmap value, which means that every bit in that register has a value, and it is a representation of the system status. And what I have on here is a really old version of DXL Administrator of the host software, so I'll get it from our website. Products. Oops. Intercom products. DXL technical manual. Scroll down to host interface specifications. Okay, so there's a current version. So I'm going to look at that. There's a register map. It shows you what the values in that register mean. Here we go. Station call status register. So this is divided into bits. So as a programmer, hopefully you know what bits are and the values are. So there are a register is a 16-bit, so it has 16 individual bits in a integer register. So the lowest bit is bit 0. So that's whether the station is in an audio connection or not. So this is a 0 if it's off and a 1 if it's on. The second bit is whether you're listening to music. So not really applicable, but it'd be 0 if nothing else was on. If this was on, it would be off. It would be 0. If it was on, it would be a value of 2. Call request pending. If the call request is active, this bit will be on. If everything else was off, this would be a value of 4 in this register. So value of 1 would be it's in a call. Value of 4 means it's that a call request is pending. So there are various other values in these registers. So whether there's an audio level alarm pending, whether you're paging this one, whether you're monitoring it, whether it has a panic call request active, and this bit 7 is whether it's faultless. So this is it's 128, value of 128 if it's faulted. So that's another useful one, as you can see if the station is disconnected or not. So if I was to go, so that's the important ones is if bit 0 is on or value of 1, you're going to call. If bit 2 is on or value of 4, there's a call request pending. If bit 7 is on, value 128, that means you have a fault. So now that gives meaning to what this number is. Bit value of 4 means that bit 2 is on, it means that it is calling in. If I was to use the master to answer the call, you'll see that value change to a 1. That is bit 0, which is in a call. So now it's gone from call request pending to in a call. I could hit the button to end the call over here, and it goes to 0, not connected. The fault bit is bit 7, which is value 128. So if I disconnect the intercom, you'll see it go to 128. So it knows that the intercom has a wiring fault on it. So we can use that a little later. So that's what happens when you have a call in, you press the call request, you answer the call, you'll see those values change. Now we can use those. Actually, one more thing I'll do is I'll do that call request again. When I answer the call from the master station, you're going to see these two registers in the corner change. So that's the master status register. So this first register says that you are connected, what you are connected to. So this value of 1 means you are connected to an intercom station. The second register says you are connected to the number 101. So you're connected to intercom 101. So you can use that to determine what you're currently in a connection with. So that could be used in our logic later. So I'm going to change my logic now to address that. Now, I've already programmed this button. If I click it, it will send the end call command. So let's see what happens. You see, you hear the call ended. You'll see this value change to 0. It's connected to nothing with number nothing. These are the command. This is the command that I just sent. I sent the change register 1 to 10. 1 0 0 0. So this is the command that I last sent. So that's when I click on this button, that's what I sent. So that's just kind of just a diagnostic for me. Yes, what I clicked on, that's the numbers that I just sent after I clicked that. So now I can go and do my second round of now I know what these numbers work, how these things change. Now I can go back into my screen and now I can actually do something useful with it. So the first thing I want to do is I want to make this change when the intercom is calling in. So the first thing I want to do is I want to have it when it's calling in, I want it to flash. So I'm going to go into this blink section. I want it to blink. I want it to blink yellow. And I want to blink when bit number 2 of that station register turns to on. Station 1 status. And in the case of Wonderware, that's period 02. So bit 2 of the station, when that is on, and you can optionally put equals 1, but this is a bitwise. So when that bit is on, I want it to flash yellow. Okay. I want it to turn green when I'm in a call. So I'm going to use the fill option. when station 1 status hit 0 is 1. Oh, I'm showing you that. So if 0 is on, I want it to be red, green. If it's off, I want it to be dark gray. Now, when I click it, I want to call that intercom. Double click on this, click on the action, command. Now, I mentioned previously where if you want to make sure you write the first command register last, if it's not written all at once. My case with my Wonderware, my driver, I know for sure that my masters, any commands I enter in one of these scripts will be sent all in one block. So I have things organized in a logical order. I have command 1 equals whatever, command 2 equals whatever. If your driver, for whatever reason, writes them one at a time, you may have to do the command 1 at the very end of your script. But in this case, to make it logical and because I know it's sent as one block, I'm just doing it in order. So command number 1 is going to be 7, which is the intercom call or ICAL command. And I want to connect from master 1 to station 101. All right, so here's our first approximation of our touchscreen. Go to my runtime options. So there's my running system. You'll see my icon now changed to dark gray, so that's kind of indication that the station is not in a call. So what happens when I press my call button? Good. It's changed to value 4, which is bit 2 on. It's just flashing the icon in a call request. It's in a call request pending. I can click the icon. It sent the iCall master 1 station 10100. Change to value 1. Change to green. You're in a call. You're talking. Test 1 2. Now with the logic I have it right now, clicking it just connects to it. So clicking again doesn't do anything because we're already connected. But so that's what I have, this end call button. So I can use the end call. It'll end the call. Send the command end call master with the zeros, and the intercom goes to gray again. Good. But most cases you want to have it, you click an icon, you want to, if it's ready in a call, you want to click it, you want to end the call. So let's put a little extra logic underneath that button. Click on the action. All right. So what do we want to do? So we want to, if you are not connected to this intercom, you want to connect to it. But if you are already connected to it, you want to end. So if, and that information is available in this master connection status. So it tells you what, if it's connected to something and what it's connected to. So we'll use those. If master 1 status, if you are connected to an intercom and put another bracket on here. If you are connected to an intercom and you are connected to this intercom, then you want to disconnect. You want to send the end call command. This master number, and then the remaining arguments 0. Otherwise, you want to send the intercom call command. Makes sense, right? Hopefully. So if I am connected, oops, put another bracket in here, and put another bracket in here. If this master is connected to a station, and the station is station 101, the icon we're working on, then end the call to master 1. Otherwise, do an intercom call from master 1 to station 101. All right, well, let's try this again. So clicking the icon should connect to that intercom, whether it's in a call, whether the call request pending or not. Call master 1 station 101. It is connected to a station numbered 101. So now that logic should see that it is connected to station 101 and send a disconnect call command when I click it. And I just lost my cursor again. There it is. All right, so I'm back again. So now that I'm connected, clicking it again should disconnect it because it saw that it's connected to this one. And there you have it. That's the basis of your intercom development. Once you've got the groundwork done, if I want more intercoms, now there's a better way of doing this, but I'm just kind of. And then I can go in here and I can go substitute tags. So whenever it says S1 status, I'm going to change it to S2 status. Substitute tags. Whenever it says S1 status, I want it to be S3 status. And so before I do that, I gotta do something else first. But that's kind of what you do. I'm just gonna do 1 and 2 there, because I'm gonna do another change. And that doesn't change the script behind it. So whatever I do, whatever actions I have for a click action, I still have to change a little bit. So that changed my blink to S2. That changed my fill color to S2, but my button presses still need to change. So now I gotta change. This is now intercom 102. So I gotta say this is for 102. And we're connecting to 102. So we'll have to do a little bit of script changing. For those of you that are Wonderware experts, is there a better way of doing that? No response. Maybe there isn't. Okay. All right, so now if I do that and I do the run, I'll see the 2 intercoms. Now my second one isn't connected, so you see this 128. The intercom system will allow you, if an intercom isn't wired in, it'll still let you connect to it, but you're obviously not going to get any audio because you're connecting to a dead port, a port that's not connected to anything. So I can click it, and it will connect to it, but you'll have no audio on it. But it knows it, it does the connection, and it connects to whatever's on that port, but there's nothing on that port. But one thing that you'll notice here, so if I'm connected to intercom 2, 102, and I click on the icon for 101, it's going to disconnect automatically from 102 and connect to 101. So I can go click on this, you'll see this one go to gray, and that one go to green. So it knows that It knows it's disconnected, so it sends you the disconnect command. It does the update of the status, and I can click on this to end it again. Gonna do a couple more other little changes. So I'm gonna first move this push to talk button out down a little bit. I'm gonna put this one down a little bit. I'm gonna name this one a little different. Call it next call. I'm going to add another little icon here. That's a sad looking triangle. No, I don't want that. It's a delete key. There we go. What I'm trying to make is a little warning triangle. I got the wrong thing again. There. I'm gonna make that yellow. And I'm gonna put a little exclamation mark in it. What's this for, you say? Well, this is going to be for if the intercom has a problem with it. I'm going to make it visible if station 1 status bit 7 is on. Whoops. Station 2. So this is what I'm talking about here. Master station 1 is connected, station 2 has a fault. So I have a little fault icon showing that that intercom isn't working. So if you want to do that, make it easy for your maintenance staff. So you can train the correctional officers that, hey, you got that icon on there, that intercom has a problem. Call up the maintenance, and then they can also know that, you know, hey, they can't talk to that guy because that intercom isn't working. So we'll do a couple other things. So this is the basics of this. I'm going to go spend another 5 minutes or so just adding some additional features. But you could basically, you know, read the all the commands you do. You can create a button to do that command. We have so I'm going to create a next call button which will answer the top call on the queue. I'm going to create a push to talk button so you get an on-screen push to talk. So you don't necessarily need to use the physical push to talk button. If the staff member are at their screen and they're pressing the button, if they're clicking icons on the screen, they can easily click the button on the screen to talk rather than having to reach over to the master station and press the button on the master station. So we can have an on-screen push to talk. We can have, I'm going to put a queue on here. I'm going to do next call, but the rest of this is just basically all optional. Now, while I'm adding these additional features, does anybody has any questions or anything else they want to show or look at or? No? far, no response on that. So I'm going to add a next call. And I don't recall exactly what the next call is, so I'm just going to look at my little cheat sheet here. So I can look at the host interface spec and find out what the next call is, so I can go find next. That is command number 21. 21. Next on master 1. Okay, good. Semicolon. Whoops. 21. And I have a push to talk. So I'm looking when I do my reference here. Push to talk is command number MPTT. So that's this command right here, command 249. Click on this. So when I am holding it down, my memory is 249. When I'm holding it down, 249, master 1, talking. So the optional X second parameter is that whether you're talking or listening. 249, okay. And when it gets released, master 1, release. $249, 1000 on release. Now you can do a fancy logic if you want to have your, if they want to have a push on, push off, you could do your logic for that. You have to have an internal status probably. I'm going to have a little text box over here. And no, I do not want it bright yellow. Yeah. Where's the reorder? It's the way around. Oh my God. Went right out the window. Oops. Yeah. There we go. So I have this as a simple representation of my call queue. And so this is going to be, so normally it's the call queue is going to be 1 and 2. So 1 is the type of call, 2 is going to be the number of the call top on the list. So I'm going to exclude the type of call. So all I'm going to see all those call-ins are going to be station call-ins. So this is going to be queue register 2. So I'm going to display master 1, queue register 2. This is going to be 4. This is going to be 6. This is going to be 8. And this is going to be 10. The heck, I'll do a fancy here. I'm going to do another couple of little buttons. So I have an on-screen volume control while I'm at it. And the command for the slots master volume. So we can actually have a volume control for the master and for the station. What I do for the master. So master volume MVOL. I'll look up what the number for that one is. MVOL. Oh, VAD. MVAD. Master volume adjustment. Command 23. 23, master number, and then up or down. Actually, it's going to be more than that. Let's look at the specs here. Page 87. RJKLM. Master mute. Master volume adjustment. So the master number, and then the up or down, and then you can change the volume on either the master speaker or on the whatever the master is talking to. So I'm going to be changing the master speaker volume so that destination could be 0. Yep. So I'm going to say master volume adjustment, master 1, increase on the master speaker. Okay. So I'm going to do that. And I got to do the master volume down, click on the action, and it's going to be master volume for master 1, adjust it downwards on the master speaker. All right, so that's this is my next iteration. So I can press my call button. So the intercom is calling in. My queue says my top call on the queue list is intercom 101. And you look at it, yeah, that makes sense. I can connect to it. I can adjust the volume up or down. You can't hear it, and if you were able to hear it, you'd be able to get feedback. But I can you can make the, without having to use the volume adjustment on the master, you can adjust it up or down. And I can use the end call. I'm just going to do a couple more things here. So I did a next call option. So if I have a, now I really only have two intercoms really connected to this. So I pressed intercom 401, which I don't have an icon for yet. So that's why I don't see anything flashing on the screen, because the icon for the 401 isn't on this screen. So the top of my queue list is 401. The second one I called in, I pressed in was 101. So I can click on the next call, which will call the top one on the queue. So it's going to call 401. So 401 is not shown on the screen. So when I do this, you're going to see that it's connected to 401, but you're not going to see any update on the screen because we haven't created an icon for that one yet. So it's currently connected to 401, and now 101 is at the top. If I click on next call, now I'm connected to station 101. 101's top on the list. If there's nothing on the call queue and you click on the next call button or use the next call feature, it's going to end whatever you're connected to, and you're going to be basically waiting. So click on next, it disconnects, and now we're totally idle. So that's what I wanted to cover today. If anybody has any questions, let me know. We can go over it now. Other than that, this is all what we wanted to cover. And thank you very much for attending. Hopefully you guys got some useful information off of this. Garrett, what's your question?
It's about the IMS station, the IMS master you got there.
Okay.
Just in your, in your picture there. So I know on the right-hand side we have those feature keys, right?
Correct.
So I think, I don't know, there's like 15 there or so.
Yep.
But just to the right of them, there's like an LED next to the feature keys as well.
Okay.
What exactly does that LED indicate?
Okay. So I actually didn't go into that, but actually I should. That's a good point. That's a good point to cover. So if you're using the key, so the buttons will, when you configure the switches. So I configured, when we configured this configuration, we configured switch 1 to call intercom 101. So I can do that. I can use it, and it calls to intercom 101. So I've programmed it as a speed dial button. The LED, you can program to do what you want, and commonly, a very useful feature for that is I can have the LED, if intercom 101, so particularly if you don't have a graphic panel or touchscreen and you want to have kind of a master station that has very limited amount of inputs and outputs, and you don't necessarily want to look at the screen, you can program the LED. So if I have this LED is associated with the intercom 101, I can program this LED so that it will turn on when you're connected to station 101, and it'll blink when station 101 calls into this. So you can program to do that. I'll do that right now. That's a really something that can be covered. So you can use it to, this as a very limited function control panel, is that you can call intercoms. And you'll be able to see the intercoms whether they're calling in with the blinking light. By default, when you create switches, it doesn't create actions for the LEDs. So you have to do that manually or separately. So that's a good question, and I'll just show you how you do that right now, because that's actually pretty simple. Well, you could do a lot of things. It doesn't have to be that. It doesn't even have to be associated with a station, but that's a common use for that. So I'm going to first of all save it as a different name. I'm going to go to the masters, configure masters. So I configured the speed dial switches under the switches tab. So I have a call in for station 101. I'll just do this one for 401. Call intercom, call end. This is going to be for 401. That's my other intercom I have readily available. So that configures the switches. The LEDs are configured in the outputs. So likewise, there are 14 outputs representing the 14 LEDs along the side. So I'm going to say number 1 going to be, so the switch panel actions are what represents, so if this split button calls a station, you can have a switch panel action for the station that turns the LED on depending upon what the station is doing. So I'm going to do a switch panel station indicator. So a switch panel station indicator will turn the LED on. Okay, yeah. And station 101. And I do a switch panel station indicator for the second one. And then that will, the LEDs will come on representing the status of that station. Does anybody else have any questions? And my system is rebooting. And the master station updated. I'll clear all the faults that are reporting to it. So you'll see its station's calling in. I press the Intercom 101 and now the LED is flashing indicating that Intercom 101 is calling in. You can press the button, connects to the intercom, goes to a solid indicator indicating that you're currently connected in a call to that one. I press the second one, disconnects from the first intercom station and connects to the second intercom station. So you can use that as a, much like you have on an office telephone, you can select an intercom to call up to, and you'll see the status of whether it's calling in and whether it's you're in a connection to it. So I can go press the call in for 101 again, and you see it blinking.
Yeah, very interesting.
So there's other things you could do with that, but that's the most common things you do that. So, for example, also another thing you might use this for is a page announcement. You make a page note. You have one of those as a. You might have them instead of calling intercoms, you might have it calling a page zone. So when you're connected to the page zone, that light will light up, just indicating that yes, you are connected to page zone. For a call, so you notice right now I have it call. You press it to call. You press it again to end the call. That's what we call a momentary switch. You press and release it, that does one action. You press and release it, it does another action. Calls it when you start, it ends it when you end. For a page announcement is a one-way call. So you can do a page announcement the same way. You press and release, you start the page announcement, you talk, and then you press and release it again to end the page. In the configuration for the station, for the switches, so if I just go back into the switches here, I'm going to save it as again. Master control 1, switches. So I could do like a page switch. And pick which page zone, so I don't have a page zone. But further information on this input tab, this contact type says a momentary means you press and release it and it does something until you press and release it again. A latch switch means that it does one thing when you press it does another thing when you release it. So for example, if you have a paging switch configured as a latched switch, it means that when you hold it down, you're paging and you're talking. When you release it, you stop the page, you stop talking. So these can be configured as a page. So you hold it down, you make a page announcement, you release, the page announcement stops. Or you can configure it like the station, you press and release it, you page, and then light can turn on, so it can indicate to the staff member that yes, you're still in a call, even though the display shows it too. But they can look at the LED if they're not really, they want to just do it at a glance. The light turns on and say you're in a call, and then you press it again to end the call, to end the page announcement. So there's a bunch of other things you could do with it. Page announcements. You can have this. You can have a button to automatically unman this master, so they can have an unman button, and then the light can be indicating whether it's manned or unmanned. But again, the display will update. But features for masters without a keypad display, for say, for example, a PMM 641 master. So this doesn't have any additional buttons, but you can wire up a button to anything on our status input. So you can have speed dial buttons, say on the station panel interface, as an example, will be like these speed dial buttons that you can do things with on your own panel. But you can do buttons on a control panel or something to do page announcement to a specific zone, which is created as a switch on the master configuration. That will be a page switch, and you pick in the switches, you pick the external switch input. So it might be on a MasterCard, it might be on an RT10, anything that has a switch on our system, you can use to trigger that action on even a master without a display on it, without the speed dial buttons. All right. I'm definitely, if you have any questions after the session, or it's you got some ideas and you got to think about it for a while, I'm always available to answer your questions. So you give me a call. I'm at extension 3535, and host interfacing is my forte. I know a lot about this, but about the intercom system in general. You got any questions? You get any possible applications? Got any ideas? Let me or Peter know. And other than that, I hope you enjoyed the session. I will try to get back to you guys and email you with a survey as to how you thought, how the session went, what went well, what didn't go well, what you would like to see in the future. So I will probably be sending you an email with those, probably not right away, but within a couple days. Other than that,
Darren,
yes.
there's a few questions in chat that maybe you want to check out.
Okay, let me take a look.
It's just about the remote SIP tab on the master.
Okay. The remote SIP tab. If I go into the master, so that is a very specialized option. So if you are using a tablet as a phone, you don't need to worry about that remote SIP tab. So the remote SIP tab is only if you are if you're having an interface between the intercom system and your facility telephone system using an Ethernet SIP trunk between the two systems. So between the intercom system and the SIP system and the phone system for paging and whatnot. Now, the most common way is the phone system can be configured to be a telephone could be configured as a telephone on the intercom system. So it's configured as a SIP device on a foreign exchange. That would be our system. So our system is a telephone exchange. If the phone system was configured that way, again, they don't need the remote SIP tab. But if they're configured as phone system to phone system, the remote SIP tab has options that it can, the Harding system can make a connection to another phone system as a phone system to phone system connection to connect to a phone or a trunk line to a phone system. So the intercom, you configure a master station on the intercom system. You configure it as an IP master. On the other system, so whoever's programming the other system, they'll create a third-party phone on their system. So they'll create a phone ID on their system, and the intercom system will call in so it'll register to their system as a phone on their system. So the URI is going to be the account information on their system for the intercom system to register on the third-party SIP system. And the password is the password that it will use to register to the third-party system. And once it's registered, if the intercom has, if there's a intercom call request that would go to a master station, so you configure this as a master station, you have the intercoms that will call into the phone system would have this master number specified as as their master, so that what would normally show up on the IMS 640. So that's the call-ins. This has a call-in from Intercom 101. So if 101 was had a master or master group that can contain this phone master or this remote SIP master, then what will happen is when a call-in comes in, so in this case we have a call-in from 101, this URI to call into is going to be the dial number on the phone system of the phone that will receive this call-in. So you can have call-ins that go to the intercom system get directed to a specific phone on the phone system based on the URI to call. Which phone, which account, which device on the phone system does the master, anything destined for this master go to in the phone system. So you have the URI, the server URI is how the DXL system registers with the foreign system, and the URI to call is the phone on the phone system to send call requests to. Does that answer your question, or confusing, less confusing?
Yeah, it certainly answers kind of the purpose of that tab, I guess. It would be great if I could see maybe an example fill-in of the tab of the kind of thing there as well. That would be great.
Okay, that was Garrett.
That was me, yes.
Okay. I don't think I have my notes on that exactly, but yeah, I can certainly give you an example on that.
Yeah, just so I know the proper syntax to use in those kind of.
Yeah, that's exactly it. There is a syntax to use on it. It has to have a specific. It's not it's the basic information is the account number, account name for the server URI, and the phone to call on the URI to call. But there's some additional string that's needed on there. But that's easy enough. I can send that to you.
Okay, great.
All right. Past lunchtime was probably way past lunchtime for you guys, so thank you very much for attending, and just give us a call if you got any questions. All right, thank you.